Okay, so again, good morning, everyone. It is our great pleasure to welcome you to the second day of the Natural Science Baltic Conference. Uh, it's our great pleasure to have you all here. We hope that the registration process went smooth and that yesterday's event was a big source of knowledge for all of you. Um, so a quick reminder, and for people who joined us today, our conference is interdisciplinary. The conference has three main research fields, research topics: chemistry, biology, and physics. It is important to note that the conference is international. We are pleased to welcome speakers from 8 countries and 27 different scientific centers from around the world. And we would like to stress that thanks to the use of online communication tools, our conference is and always will be free of charge. The main organizers of the conference are Students' Science Club for Chemistry at the University of Gdańsk, the Doctoral Student Council for the University of Gdańsk, the Chemistry Student Council of the University of Gdańsk, and the Center for Student and Doctoral Activities at the University of Gdańsk. You can view the full organizational committee on our website. The event is under the patronage of the Fahrenheit University, Polish Chemistry, the Polish Chamber of Chemical Industry, the National Representation of Doctoral Candidates, the Polish Academy of Sciences in Gdańsk, the Dean of the Faculty of Chemistry at the University of Gdańsk, and the honorary patronage of the Rector of the University of Gdańsk. It is also supported by the Pomeranian Voivode, the Agreement of Academic Technology Transfer Centers, eDoctorant, and Now Environment. Additionally, we would like to thank and acknowledge the great scientific contribution of the scientific committee, which for this edition of the conference is Professor Anna Axman, Professor Marcin Marciniak, Professor Henry Pinto, Professor Katarzyna Wiktorska, Dr Elżbieta Adamska, Dr Emilia Godnarek-Castro, Dr Amon Desai, Dr Agata Kućko, Dr Małgorzata Kapusta, Dr Anna Pancielejko, Dr Maria Madej, Dr Monika Hejna, Dr Magdalena Medyńska, Dr Katarzyna Węgrzyn, Dr Dawid Wnuk, Dr Dawid Zych, Dr Wojciech Snoch, Dr Wojciech Siwek oraz Dr Maria Kochaniec. The patrons, yesterday we had the great pleasure to listen a keynote lecture by Dr. Manuel Banzhaf from University of Newcastle. And today our special guest will be Dr. Joanna Drzeżdżon from University of Gdańsk, who will give us a lecture on self-healing polymers. So we welcome the special guests and we are very thankful for their contribution to the event. We also welcome the speakers for the presentations and posters. Please remember that you have 13 minutes for your presentation and the time for discussion for each presentation is planned to be around 2 minutes. The poster session will take place later today. All poster presentations are available at all time as a video, and the discussion on the poster session will take place later. You can access the posters on our website with the password, which is now presented on the screen. In case of any problems, you feel free to contact us at the provided email. And we hope that you'll have a great second day of our conference. So with this, I would like to invite you all for the presentation of Professor Joanna Drzeżdżon. Okay, so the...
Good morning. My name is Joanna Drzeżdżon and I work at the Department of Environmental Technology, Faculty of Chemistry, University of Gdańsk. It's a great honor giving this plenary lecture, so thank you for inviting me. Today, I will introduce the topic of self-healing polymers with a special focus on the role of coordination compounds in polymer formation and self-healing processes. Self-healing materials are designed to repair damage initiated at the macron scale, effectively impeding the propagation of the damage and extending the shelf life of the materials. Novel technologies such as hollow glass fibers, optical fibers, and microcapsules are utilized to manufacture specialty composites depending upon the intrinsic and extrinsic types. The global self-healing materials market size was estimated in USD 2 billion in 2023 and is projected to grow at a compound annual growth rate of 24% from 2024 to 2030. The market growth is attributed to the increasing demand for these materials from the construction, electronics, and automotive industry. Self-healing materials are smart materials that can automatically repair damages caused to them due to the mechanical impact and restore their functionalities. They are triggered by environmental stimuli, including alterations in UV light and pH, or by mechanical damage, such as a microcrack. Demand for advanced self-healing polymers is extremely high owing to the result of improving productivity and minimize losses linked with product damages, particularly from automotive and electronic devices. Manufacturing industries is anticipated to drive the market growth. Also, upsurge in the application of such materials in paints and coatings in the above-mentioned industries is expected to endorse growth. Growth in the construction sector, for example, in the USA, is responsible for self-healing materials market growth in the region and is expected to observe notable growth over the forecast period. Increased demand for energy-efficient construction solutions is one of the primary factors driving the market growth. But on the other hand, high acceptance of the product and demand by the application industry is expected to contribute to the market growth. Electronic giants such as Apple or LG are recommending the usage of self-healing materials in electronics such as laptops, desktops, and mobiles. Rise in the capital expenditure by the companies in the industry is expected to open up new opportunities for market growth over the forecast period. Furthermore, factors such as the high cost of such products, together with the existence of a number of substitutes in the market, projected to hinder the overall market growth. Conversely, partial awareness of the products, mainly in the developing economies across the globe, is expected to limit the market growth over the growing year. Self-healing polymers have the ability to regenerate and repair damage, making them very intriguing for various applications. Here are a few main areas of their use. For example, self-healing polymers are used in the production of building materials such as concrete and asphalt. They can reduce infrastructure maintenance caused by decreasing the need for frequent repairs. In the electronic industry, such as display screens, self-healing polymers can help maintain functionality and extend the lifespan of devices. In applications where weight and strength are crucial, self-healing polymers can aid in ensuring long-term performance and structural safety. Self-healing polymers are also applied in the production of protective coatings, such as paints or anti-corrosion coatings, to enhance durability and resistance to mechanical damage. In medicine, self-healing polymers can find application in biomedicine, for example, in the production of biodegradable implants that can repair themselves at the site of implementation. In the energy sector, self-healing polymers can assist in maintaining and repairing structures associated with wind power, photovoltaics, or energy grid infrastructure. Each of these areas benefits from the self-repair capabilities of these polymers, contributing to the reduced maintenance costs and enhanced longevity and performance across a range of products and constructions. What about the role of biomass in self-healing materials, polymers? Biomass plays a very important role in self-healing materials. In general, the role of biomass in self-healing materials can be classified into the following section. First, as a template material for grafting to form substances with target functional groups. For example, the active hydroxyl groups on cellulose can also be used in grafting reactions to form new compounds for other self-healing reactions. For example, hitosan can provide nitrogen H2, which can form enamine bonds. The oxidized sodium alginate containing CHO groups can be polymerized with a substance providing NH2 functional groups such as acrylamide to form acylhydrazone bonds to self-healing. In the second section, the biomass can play a role as a filler, provides a support frame for the material, or as a dispersant, avoid agglomeration in the gel, or as a cross-linking agent, making the material better cross-linked at polymer site, or biomass can be adjust the mechanical properties or viscosity of the material. So, why are not all materials self-repairing? Why is it that if you cut a metal, it will not repair itself? Metals have a regular crystalline structure in which the atoms are closely ordered and bound together by strong metallic bonds. When a metal is cut, these bonds are broken, leading to permanent damage to the structure. So only some materials have the capacity to self-heal. For example, we cannot classify plasticine as a self-repairing material. Once plasticine is formed and shaped, it can be easily deformed, stretched, or crushed, but it doesn't have the ability to self-repairing in the sense that self-repairing materials do. For example, self-healing polymer is not sticky, but it does stick to itself. Detailed classification self-healing mechanisms are shown in the figure. Polymers with intrinsic self-healing capabilities are designed at molecular level to incorporate specific functional groups or dynamic bonds that can reversibly react upon damage. And the concept often involves using dynamic covalent bonds or supramolecular interactions within the polymer network. These bonds can break and reform in response to mechanical stress or other stimuli. When damage occurs, such as cracks or fractures in the material, the dynamic bonds or interactions within the polymer can undergo rearrangement or healing processes on their own, sealing the damage. Intrinsic self-healing mechanisms offer advantages such as continuous maintenance of material integrity, extended lifespan of products, and potential reduction in maintenance and repair costs. Materials with intrinsic self-healing properties find applications across various industries, including aerospace, electronics, automotive, and infrastructure, where durability and reliability are crucial. The human body has a complex system to patch up the skin injuries. All wound healing stages are essential for proper recovery. It is the first phase of healing and begins at the onset of the injury. At this stage, the blood clotting system is at work to try and stop the bleeding. The platelets in combination with collagen can result in the activation and aggregation of blood clots. Once blood flow has ceased, the damaged tissue will begin their restoration phase. This stage may last up to 2 days, depending on the severity of the wound. Once phase 1 is complete and the wound is no longer bleeding, the body will activate its key defense mechanism. The second phase, also known as the defensive or inflammatory phase, is about destroying bacteria and removing dirt. This stage is essential to prepare the tissue bed for the growth of new tissues. The white blood cells will enter the wound to clear the debris. They can secrete growth factors and proteins, prompting cells within the immune system to begin tissue repair. The defensive or inflammatory phase can last around 4 to 6 days. It is often accompanied by symptoms such as pain at the injury site, edema, erythema, and heat. This is because of the blood that rushes to the wound to repair it. The focus of the proliferative phase is rebuilding new tissues made of collagen and extracellular matrix. It features three distinct stages: filling the wound, contraction, and wound cover. The first stage is the formation of shiny, deep red tissues, new blood vessels, collagen, and other connective tissues that will fill the wound bed. Next is the contraction, where the new tiny capillaries or margins will pull toward the center. The new cells will arise from the margins to cover the wound with epithelium. The proliferative stage often lasts from 4 to 24 days. And the final phase is known as the maturation or the remodeling stage. The new tissue slowly develops its strength and flexibility. Here, remodeling of the skin happens and the wound completely closes. The collagen fibers will begin to align and there will be an overall increase in tensile strength due to cross-linking. The maturation stage varies from each wound, but it often begins one day following an injury and can last for a year or longer. Skin is the first protection of the human body, and it is also one of the largest organs covering the entire body. Skin has many functions. It can control the body temperature, feel stimulation from external sources, and moisten itself by secreting sebum in normal conditions. In addition, skin can self-heal when injured. Various artificial skins have been studied for the body and biomimetic bodies, such as artificial skins are made from various materials, such as polyurethane, graphite, nanofiber fabrics, and gels. Among these, gel artificial skin is the most abundant. Okay, and artificial skin is a collagen scaffold that induced regeneration of skin in mammals such as humans. The integration of multisensory ability into a single functional layer has been demonstrated, and a human touch sensing electronic skin with the thermoelectric properties of graphene and heat-activated piezoresistivity was fabricated. Him and his co-workers utilized nano ribbons of single crystal silicon to form sensor arrays to detect strain, pressure, and temperature. And an interesting group of self-healing materials is based on polyolefins. On the slide, I presented an example of a self-repair process diagram of a polymer fragment. In the first stage, the so-called mobile phase caused by the damage is activated. Then the self-repair process proceeds. This process depends on the type of material and can occur through hydrogen bonds and dispersion of polymerization polyether chains, or with the use of capsules and channels containing monomer and catalysts. Finally, The crack is sealed and immobilized. Why are polyolefins an interesting research topic? Because it is hard to find an area of life in which they wouldn't have applications. It can even be said that each of you has surely come into contact with plastics in the last 5 minutes. The three main groups of polyolefins used in the industry are polyethylene, polypropylene, and polybutylene. Polyethylene is the most commonly produced plastic. It is a polymer primarily used for packaging, for example, plastic bags, plastic films, geomembranes, and containers, including bottles. As of 2017, over 100 million tons of polyethylene resins are being produced annually. Polyethylene is usually a mixture of similar polymers of polyethylene with various values of monomer numbers. It can be low density or high density, and many variations thereof. Its properties can be modified further by cross-linking or copolymerization. All forms are non-toxic as well as chemically resilient. Polypropylene is a thermoplastic polymer used in a wide variety of applications. It is used to produce syringes and, for example, polypropylene tapes. Polypropylene belongs to the group of polyolefins and it's partially crystalline and non-polar. Its properties are similar to polyethylene, but it is slightly harder and more heat resistant. It is a wide, mechanically rugged material and has a high chemical resistance. And polybutylene is a thermoplastic material in the polyolefin category, together with other plastics such as polypropylene or polyethylene. It is included in the group of nonpolar plastics. Nevertheless, compared to these plastics, polybutylene is more lightweight and flexible and has greater pressure resistance for the same weight. It is used in the manufacture of hydraulic system components because it prevents water migration. Polyolefins can be obtained by various methods. One of them is cationic or anionic polymerization. Here the catalyst is provided in the form of an ion. Another method is free radical polymerization. In this stage, a free radical is generated on the carbon atom of the monomer. It is used, for example, to obtain polystyrene. Another method for obtaining polyolefins is ring opening metathesis polymerization. The catalysts used in this method are mainly based on ruthenium ions, are the so-called groups catalysts. And another important method for obtaining polyolefins is polymerization using a coordination mechanism. Ziegler-Natta catalysts are often used here. Why is coordination polymerization so important and interesting for research purposes? Because it has a number of advantages that set it apart from other polymerization methods. For example, a wide range of applications, small amounts of initiator, or high product purity. Among the huge group of transition metal-ion complex compounds, it is worth noting vanadium compounds that act as catalysts in the polymerization of various olefins. Analyzing the literature data on vanadium complex compounds in the fourth and fifth oxidation stages, it can be noted that complexes containing such donor atoms as oxygen, nitrogen, and sulfur are known among effective catalysts. In addition, ligands that are phosphines and their derivatives also appear. Previously, our research group has taken on the study of oxovanadium complexes as catalysts for olefin polymerization. First, we investigated dipicolinate complexes of oxovanadium-4 with aromatic ligands such as phenanthroline and bipyridine. We found that these complexes exhibit high catalytic activities in the oligomerization of functionalized monomers such as 2-fluoro-2-propan-1-ol and 3-buten-2-ol. So, we decided to design synthesis of acetyloacetonide oxovanadium-4 complexes that could potentially act as highly active catalysts. The purpose of our research is to study the effects of acetyloacetonide and heterocyclic ligands on the catalytic properties of oxovanadium-4 complex compounds in the polymerization and copolymerization of ethylene. An example of the synthesized new oxovanadium-4 complexes I presented on the slide. This is a new structure not yet described in the literature. In the coordination sphere of vanadium-4 cation are acetyloacetonide ligands, and in addition, the 2-chloro-3-aminopyridine molecule is hydrogen bonded to an oxygen atom in the water molecule, which is the ligand. The new complex compound has been structurally investigated by many methods. Among them, of course, is the X-ray method. But we also obtained interesting results using a coupled method of thermal analysis and Fourier spectrometry. The 3D diagram showed that when exposed to high temperatures of up to 1000 degrees Celsius, compounds such as carbon dioxide, carbon monoxide, and water are released. We have carried out the reaction of ethylene polymerization catalyzed by acetyloacetonide oxovanadium complex 4, which had to be activated by the ethyl aluminum fluoride. The carried out reaction of ethylene polymerization with acetyloacetonide oxovanadium-4 shows that at 20 degrees Celsius, the complex shows a very high catalytic activity of more than 4000, which means that we can speak of it as a very highly active catalyst. It is interesting that thanks to the use of oxovanadium-4 complex with acetyloacenite, a linear low-density polyethylene was obtained, while mostly with the use of transition metal ion complexes, a branched polyethylene is obtained. Comparing the results of the tests performed by our research group with other acetyloacetonide oxo-vanadium complexes, it can be seen in the table of the slide that the activities are maximum 130 for complexes containing 3 acetyloacetonide ligands. It can therefore be concluded that the added presence of the pyridine derivative that we used in our study is correct and increases the catalytic activity of the complex. With the aim of later using these catalysts to obtain self-repairing polymers, we carried out a copolymerization reaction of ethylene and 1-octane. The results of the study are promising, and I have collected them in the table on the slide. It can be seen that the oxo-vanadium-4 acetyloacetonide complex is a highly active catalyst also in the copolymerization of ethylene and 1-octane. And in the diagram, I have shown a comparison of the catalytic activities of complexes known in the literature and the one developed by our research group in the polymerization of ethylene. It can be seen that the acetyloacetonide oxo-vanadium-4 complex stands out for its catalytic activity in the ethylene polymerization process. So, what are the future research directions for this catalyst for olefin polymerization and in the self-healing polymer field? With continued development and seamless integration of self-healing materials into modern-day applications, it is set to open up a new area of enhanced consumer experience, infrastructure maintenance, environmental management, as well as countless unprecedented and unique applications resembling those in unexpected field. To achieve these futuristic technological outcomes, one should allow much room for visualizing new opportunities, possibilities by self-healing technologies in order to bring about many more useful and innovative applications to benefit the society as a whole. In this regard, it is anticipated that biotechnology and AI will play increasingly prominent roles in driving further advancements and adoptions of self-healing technologies, mainly through introducing novel enhanced biofeatures, data-driven, customized healing strategies, as well as through bestowing performance or production advantages such as mechanical robustness, ease of scaling up, cost effectiveness, enhanced biocompatibility, and, for example, eco-friendliness. So now I would like to thank you, all the people with whom I cooperate in the implementation of this research, and thank you for your attention.
So thank you to Dr. Drzeżdżon for the amazing presentation. I see that Dr. Drzeżdżon is with us here today. So if you have any questions, hello, hi. So if you have any questions, I see already some hands being raised. Okay, so first was Dominika.
Hello, thank you for your lecture. I have one small question. Are these materials expensive?
It's difficult question because this kind of materials are innovative group in the industry, but in Poland market they are also available, and for example coatings are not expensive, but only this group is available. Other kinds of products, for example, in automotive industry or packaging industry, is on studies step. Yeah.
Okay, thank you very much.
Thank you.
So the next question, Bartosz Chojnacki.
Yes, hello. Thank you for your presentation. I have a question. I understand that there is already a commercial use, but how popular it is in the commercial use, these self-healing polymers?
Okay. In Poland market, it's not popular because now some researchers groups is only investigate these materials for the industry scale, but foreign market, for example, in the USA or in the UK, this products for their market is some popular because you no need to call it mechanism or take things in for repair. So it will be popular, I think, in also Poland market. Yeah.
Okay, thank you very much.
Okay, I see one question on the chat. What physicochemical methods are used to deposit biologically active particles on the material?
Okay, mostly it's CMA, scanning electroscope, microscope, and XRD also. XPS may be used to study these physicochemical properties. What else? Also GPC or CECs, gel chromatography, also is used to study their physicochemical properties, mainly self-healing activity, but mostly CEM. Yeah.
Okay, I have also one question. I don't see anyone, so it's still time to raise your hand. So my question is, how do you strike the balance so the material can self-heal, but it's also biodegradable? So how do you make it that it's not retained in the environment later? How is it done?
Yeah. Most part of these products is not biodegradability, but yeah, in the future, the excellent life, these products must be biodegradable. But now, in this step of our studies and taking into account the products which are available in the market, most part are not biodegradable. Yeah.
Okay, thank you. I see that Wojciech Snow was the first now to raise the hand.
Good morning, everyone. I have one question about, because I saw that your catalyst is more efficient than other vanadium catalyst, is like much more active. And what do you think? What is the key feature that make it more effective than other vanadium catalysts? What do you think? What is the one thing that makes it better?
This catalyst, which is presented in the slide, have much more catalytic activity, and I think it is determined by the presence of the pyridine derivative, 3-amino-2-chloro-piperidine, because other catalysts described in the literature, also oxyvanadium 4, have acetyloacetonide ligands. So the same which in our catalyst, but the presence of pyridine derivative is most crucial in this case, but presence of the pyridine derivative may be difficult to the applied this kind of catalyst in the industry, taking into account their biodegradability, because we know that pyridine mostly are toxic, but the coordination sphere of oxyvanadium can be modified by derivatives of pyridine or acetyloacetonide ligands to increase their catalytic activity, and in the next steps, in the future steps, their biodegradability.
Thank you very much for this answer.
Thank you.
So I see one more question in the chat by Kamil Klimkowski. Are the presented polymers degradable, and are there possible risks of such degradation known? So you already spoke about their ability to degrade them, but maybe are there some potential risks of the degradation of these polymers that you could think of?
Yeah, thank you for this question, but now not yet. Degradability of catalysts studied by our group is not studied, but it will be, according to our plan, it will be investigated in the future. So I think this catalyst have potential to apply it for self-healing material in the industry in the future, of course.
Thank you very much. I don't see any more questions. Last chance. Okay. So thank you. Oh, okay. Krzysztof Polaczek.
Yes, thank you for a very interesting presentation. I have one small question. In example, shape memory polymers need to heat to take this shape. Is there in healing polymer some kind of special treatment to enhance process of healing or start process of healing?
But your question is about the polymers which were obtained by the oxo-vanadium catalyst, or all self-healing materials in the industry?
Maybe more general question.
Oh, okay. So yeah, you're right that shape memory polymers should be taken into heat or pH change or temperature or UV light, but shape memory polymers are commonly polyurethane, yeah. But in our research group now, polyurethane is a group which are not studied by, in my best knowledge, in the polyurethane also the heat or pH or UV light or the presence of other chemical compounds can induce their shape memory activity. Yeah.
Okay, thank you very much.
Thank you.
Okay, I don't see any more questions. So thank you again for the very nice presentation and for the discussion.
Yeah, thank you.
Okay, so we'll proceed with the first for today session of oral communication. Maybe just a small note that some talks will be a bit earlier than planned. So please, if you have a presentation today, please check the schedule regularly so we can do everything on time. So the first presenter in this session will be Joanna Wojtukiewicz from Adam Mickiewicz University in Poznań. Joanna, are you with us?
Yes, I am.
Great. Okay, so Joanna, please share your screen. Okay. So the floor is yours.
Thank you. Today I would like to introduce the topic of hydrosylation of carbon-carbon triple bonds, and more specifically to introduce the process itself using the example of hydrosylation of carbon-carbon triple bonds. First, however, let's talk about hydrosylation itself and what exactly is it. It's the most versatile method of organosilicon compound synthesis, and so far the only one used on an industrial scale. The hydrosylation reaction involves the addition of organic and inorganic silicon hydrides to multiple bonds, in particular carbon-carbon, carbon heteroatom, and heteroatom-heteroatom bonds. Most commonly, oxygen, air, or nitrogen are used as the heteroatom. Let's start maybe with some short background. For the first time, almost 80 years ago, Leo Sommer published an example of hydrosylation reaction between 3-chlorosilane and 1-octene in the presence of acetyl peroxide, the product of which was 3-chlorooctylsilane. 10 years later, John Spear discovered hexachloroplatinic acid, which was the first platinum catalyst for the hydrosylation process, and it also became a precursor to the synthesis of other platinum catalysts used in the process today. A little later, in 1992, Professor Bogdan Marciniec, professor at Adam Mickiewicz University in Poznań, published a book entitled Comprehensive Handbook on Hydrosylation, in which the hydrosylation reaction was described in detail for the first time, and the existing knowledge on the conditions for carrying out this reaction was collected. Hydrosylation can proceed by a homolytic mechanism in the presence of radical initiators. For example, Lee Sommer's reaction was carried out this way, or by a heterolytic mechanism via nucleophilic electrophilic catalysis or transition metal catalysis. Nowadays, hydrosylation reactions that that proceed according to a heterolytic mechanism are much more common. The hydrosylation process is one of the most efficient methods for synthesis of alkenyl-derived silanes and silcyl-cloxanes. It is possible to selectively synthesize a specific isomer formed by the addition of SEH bond to a carbon-carbon bond. And the reaction itself can be carried out in an air atmosphere under mild reaction conditions and in a wide temperature range. In addition, the process has 100% atom efficiency, and the reactants and catalysts used in the process are commercially available. Despite its many advantages, the hydrosylation process, as every process, has minor drawbacks. The organic solvents used in it are toxic, volatile, and the isolation takes sometimes several steps. The cost of the process is high, mainly due to the use of catalysts containing expensive transition metals like platinum. However, research is currently underway to use other, also commercially available, but cheaper and greener catalysts and solvents. For example, ionic liquids or supercritical carbon dioxide, which would allow lower process costs and a shorter isolation process. Using the carbon-carbon triple bond hydrosylation reaction as an example, I would like to show you how versatile hydrosylation reaction can be. During the hydrosylation of alkenes, silicon hydride addition can occur to the terminal or internal triple bonds. In the case of terminal alkenes, a mixture of 3 isomers can be formed, with the beta E isomer being the most commonly observed. In contrast, the hydrosylation reaction with internal alkenes gives as many as 4 isomers. It might seem that obtaining so many isomers would be a big disadvantage due to the need to isolate the desired product. However, by using one set of reactants, silane and alkene, and changing only the catalyst and process conditions, it is possible to selectively obtain a whole range of different compounds. The products obtained are highly reactive due to the presence of a double bond, a silyl group, as well as substitutable R and R' groups. Hydrosylation reactions can be catalyzed by a wide range of catalysts, but the most common in both industry and organic synthesis are the use of transition metal complexes. Among the most common catalysts used in the hydrosylation process are platinum, ruthenium, and rhodium complexes. Platinum catalysts such as the Spear catalyst and the Karstedt's catalyst are the most commonly used catalysts in hydrosylation reactions. They are not the most selective, but by choosing the right reaction conditions, it is possible to increase their selectivity. Combined with high efficiency and market availability of these catalysts, they are the main catalysts used in industry for the process. In contrast, the platinum-phosphine complex and its cell derivatives, due to steric hindrance, are more selective platinum catalysts and lead with high efficiency to the formation of beta E isomer almost completely. In the case of rhodium complexes, an interesting case is represented by 2 complexes whose use in the same reaction under the same conditions leads to different isomers as the main products. The use of the ruthenium chloride complex gives predominantly the beta Z isomer, while ruthenium binap complex gives mainly the beta E isomer. There are also other interesting cases in the literature where one variable results in different products. One such example is the Wilkinson's catalyst, whose use in polar solvents results in the product being the E isomer, while in non-polar solvents it is the Z isomer. Another example is the Another example is the rhodium 3,3-phenylphosphine iodine complex, where the order of addition of the reactants is the factor affecting the product obtained. When the catalyst was added to the silane first and the alkene added 2 hours later, the product was the beta Z isomer. In contrast, if the catalyst was added directly to the silane-alkane mixture, the product was the beta-E isomer. When it comes to ruthenium complexes, the most common one used in the hydrosylation process is the ruthenium dimer. It's used in reactions with alkanes, results in beta-Z alkenyl silanes, while in reactions of alkanes having hydroxyl groups in the beta position for the triple bond, the product would be alpha alkenyl silanes. The hydrosylation process has found wide applications, among others in the synthesis of silane coupling agents that are used in coatings, reinforced composites, dentistry, biomedicine. The application of hydrosylation process has been also found in the production of silicone rubber and the synthesis and modification of polysiloxanes, and also as a method for further chemical transformations. Thank you very much for your attention.
Thank you very much for your presentation. Do we have any questions? I don't see any hands. Maybe. Okay. Okay, so I think Dominika was first to raise the hand.
Okay, hello. I have one question. Can the presented method be used in surface modification of silicon materials such as silica gel?
Yes, it absolutely can be used in such modifications. As I said, this process has a very wide application, and there's a lot of literature at this point about using it in different places. So from my knowledge, yes, it can be used for that.
Okay, thank you.
Okay, do we have any more questions? Okay, if not, then thank you very much for your presentation.
Thank you.
The next speaker in this session is Jakub Grządziel from University of Applied Sciences in Nowy Targ. Jakub, are you here? Okay, I don't see Jakub, so maybe he will join later. Okay, so Daria Łada. Okay, you're here. Great.
Hello.
Great to see you.
Yes, I'm present.
Okay. So try to share your screen.
All right. I share. One moment. All right.
Okay.
Is the presentation visible in full screen?
Yes, we can see it. So the floor is yours.
Can I please get confirmation?
Yes, we can see your presentation.
Yes, it's visible.
Okay, so I ask again, my presentation is already visible in full screen mode.
Yes.
Yes.
Okay. Let's start. My name is Daria Łada. I'm a first-year PhD student at the Doctoral School of Natural Sciences at the University of Gdańsk, and I pursue my thesis at the Department of Molecular Biochemistry at the Faculty of Chemistry. And today I'll present my research concerning design and synthesis of peptide conjugates toward microbiological activity. I will start with the introduction of the topic and progress of the research. But due to time limitation, the results will be a bit simplified. But I remain open to questions at the end. Starting, it is worth noting that fungi are everywhere. Sometimes they're too small to see with naked eye, but they live outdoors, for example, in soil and on plants, indoors, on surfaces and in the air, and on people's skin and inside our body. There are millions of fungal species. Over 600 is linked with disease, but fewer than 30 cause infections. Each year, there are over 1 billion fungal infections worldwide, with more than 150 million severe cases of fungal infections, causing around 1.7 million deaths each year. Worryingly, these numbers are steadily increasing. Sorry. And these numbers are steadily increasing. Furthermore, the long-term therapeutic and prophylactic use of antifungal drugs have led to formation of multi-drug resistant fungi. Therefore, fungal infections are a global threat that is becoming more severe. The most common pathogen is Candida albicans, and because fungi gradually developing disease resistance to the drugs that have so far been used to treat fungal disease, there is need to synthesize new drugs or modify the old ones. As I should mention, Candida albicans cause a significant number of disease cases. It's a yeast-like fungal that naturally occurs in our bacteria flora, but cause infections if it grows out of control. This fungus naturally is present in the bacteria flora of the human urogenital and digestive systems, as well as on the skin, and is present there without causing problems, but is responsible for development of candidas, infection of the bloodstream or internal organs like kidney, heart, or brain if our immunity system is not working properly. In medical use, there are 4 main classes of antifungal agents dominating the market. It's azoles, polyenes, echinocandins, and other types like fluorine pyrimides. And among azoles, we can distinguish triazoles, imidazoles, and thiazoles. Part of my research will focus on the group of triazole drugs. The history of azole group dates back to 1940s, when the antifungal activity of benzimidazole was described, and further search for new OLS toxic antifungal drugs led to synthesis and clinical introduction of, for example, fluconazole, which was presented in 1981. But over the years, it has lost its effectiveness, which we are trying to restore. So after such an introduction, let's move to the results of my research. The main aim of the work is to modify fluconazole by forming peptide conjugates. In the design conjugates, selected cell-penetrating peptides and antimicrobial peptides will be present combined by a linker with modified azole drug. The term conjugate refers to a compound formed by covalent combination of two or more chemical compounds, usually of different chemical nature, not necessarily different biological activity. Peptides are the components of the conjugate that are designed to transport the drug and modify activity of all conjugate. Linkers are the groupings through which the molecules of the chemotherapeutic agent binds to the peptide. And the main idea is well illustrated by the image of toweled vehicle. An appropriately designed conjugate can more specifically guide the therapeutic to its molecular targets. Such conjugates also offer the opportunity to reduce or completely eliminate side effects and extend the half-life of the drug component of the conjugate. So the first stage of my work was to prepare a fluconazole derivative. The modification was made by combining fluconazole via its hydroxyl group with glutaric acid anhydride. This combination allows the drug to retain its antimicrobial activity and in a further step enables its attachment to the N-terminus of the peptide. We tested various synthesis conditions based on the results of another doctoral thesis and a patent which did not succeed. But finally, modification of the recipe from certain publication made it possible to obtain the plant derivative. The best results were obtained with a reaction lasting 20 hours, carried out at 85 Celsius degrees on a magnetic stir with heating jacket. Here are presented selected HPLC chromatograms for reaction mixtures number 1, 3, and 8. The visible signal with retention time about 10 minutes comes from fluconazole and around 40 minutes from its derivative, and it's only present on chromatogram from mixture number 8 in this case. After identification, we purify the compound on semi-proprietary HPLC and we're able to receive our fluconazole derivative for the next step of synthesis. So after obtaining fluconazole derivative, the next step was to synthesize the peptides, which will be also used to receive conjugates. We selected 2 antimicrobial peptides described in 2019 publication. They were optimized based on Infernon 1, cytokinase distributed by big hot carb. And we perform the solid phase synthesis with the help of an automated peptide synthesizer using the procedure described in table number 2. Ultimately, we were able to receive and purify both of these peptides. And in possession of both components, we could move to the synthesis of the conjugates. And the final step was the formation of peptide conjugates by linking the N-terminus of the peptides immobilized on the solid phase with protected sign the chains with the carboxyl group of fluconazole derivative. As in previous cases, compounds were analyzed and purified, giving presented results for peptide 5 conjugate and peptide 9 conjugate. And in the last stage, the compounds were submitted for the tests of antimicrobial activity. This synthesized compounds was preliminarily tested for the antimicrobial activity in cooperation with the Department of Pharmaceutical Chemistry and Biochemistry, Faculty of Chemistry, Gdańsk University of Technology. At this point, we have results for peptides and fluconazole derivative, but conjugates have not been tested. But as we can see, P5 peptide and fluconazole derivative gave promising test results of minimal inhibitory concentration in comparison with P10 and P9. And coming to the end of the presentation, let's summarize the results that we obtained so far. So we optimized a synthesis method that allowed us to obtain a fluconazole derivative with 76% efficiency. We have conducted a synthesis of 2 antimicrobial peptides. We subjected all compounds to HPLC and MS amylases for identification and characterization of them. Preliminary antimicrobial activity tests have gave promising results for P5 peptide and fluconazole derivative, and through comparative antimicrobial tests for all compounds will be conducted soon. So thank you for your attention, and I'm open to questions from your side.
Thank you, Daria, for your beautiful presentation.
Oh, I can hear again. So.
Great. So I see that we have one question in the chat from Camille. What molecular goal have you chosen in your work and why?
Our molecular goal is to make it easier for fluconazole to enter the fungal self or of Candida albicans, and it will inhibit the synthesis of ergosterol that is part of fungal cell membranes, and it will cause inhibition of growth of the fungal cell, and in the results it's death.
Okay, thank you very much. I see we have one more question. Wojciech Snoch,
Hi, thank you for your nice presentation and good work. Do you have any infrared spectra or H enamel or C enamel spectra proving that your synthesized molecule is obtained, or are you proceeding this because you showed us MS and HPLC, so it's good, it's fine, but I think NMR is required.
Yes,
Yeah.
for now we conducted HPLC and MS analysis, and it's the main analysis that we conduct for our compounds on our cathedra. But we also make NMR and AR analysis for fluconazole. It's derivative, and now with help of doctor from Technical University of Gdańsk,
Okay.
we probably contact NMR for our conjugates, but it's more complicated because there have more than 20 amino acids in the chain, so the analysis will be more.
There are NMR analysis of polymers, so you can do it, but it's quite difficult to analyze and understand the results, and also pick the right media to analyze, because sometimes it's well soluble in one media.
Yes, it's very complicated.
Probably
so
DMSO would be a good one to pick. And also I have another question, because you showed us that the efficiency was 76%, but it was efficiency of the reaction of a whole process, because I didn't see you mention how you purify it.
At this moment, it was efficiency of this specific reaction. In the whole process, there were
Lower.
Yes, it was lower when purifying, and all. It was the result for reaction based on HPLC analysis.
But how lower? How much lower it's comparing to?
After purifying, it was about 56%.
Oh, it's okay.
So it's not that bad.
It's not bad. It's not bad. Not at all. So thank you for your presentation and answering the question.
Thank you for your questions.
Thank you for a very nice discussion. If you have some more questions to Daria, I think she will happily answer if you contact her later. But now we have to continue with our schedule. So thank you again, Daria. And the next speaker is Aleksandra Liczbińska from University of Gdańsk. Aleksandra, are you with us?
Yes, I'm here.
Great. So try to share your presentation.
Okay.
Okay. We can see your presentation.
Everybody can see my screen? Yep.
Yeah. Okay. So the floor is yours.
Okay, thank you. So good morning. It's really nice to be here. My name is Aleksandra Liczbińska, and I'm a student of doctoral school of the Gdańsk University of Technology. And I want to present the topic, which is strictly connected with my project regarding managing the phosphogypsum landfills and other hazardous waste from chemical industry. So today I want to talk about development of phosphogypsum landfills as a way to reduce eutrophication of the Baltic Sea. But from the beginning, what is an eutrophication? It's a process in which nutrients accumulate in a body of water, resulting in increased growth of microorganisms, what may deplete the water of oxygen. It's a natural process, of course, but pollutions and humans' activities causes rapider blooms and bacterial growth. Main activities, apart from those natural, are, for example, a larger share of agricultural areas than the forest areas, increase the fertilizer consumption and efficiency of sewage treatment. All of these mentioned reasons affects in increasing the nitrogen and phosphorus load in the seawater, increasing the density of marine flora, reducing the amount of light and oxygen loads, which affects in aerobical bacteria growth and increasing the hydrogen sulfide load. So can we say that
sorry for a second, but we don't see you changing the slides. So if you can try to change it somehow.
It was my biggest nightmare today, so
Don't worry, don't worry.
So maybe that way it will be okay. And now it's works?
Yes, now it's working.
Yep. Okay. So I will continue. So can we say that the Baltic Sea is suffocating? Of course, yes. Why? Because 1/3 of the sea is hypoxic and 1/5 is already dead. So now I would like to talk about the HELCOM. HELCOM is the Baltic Marine Environment Protection Commission and consists of the 9 European countries like Poland, Denmark, Estonia, Finland, Germany, Latvia, Lithuania, Russia, and Sweden. And the official 10th member is European Union. Why I would like to mention about that, because almost 77% of deposited and almost 50% of oxidized nitrogen and phosphorus compounds enter to the sea from HELCOM countries. Almost 100% of Poland's area is located in the Baltic Sea catchment area, and 2 large rivers flow through it, the Vistula and the Odra, and these both rivers collect nutrients from the land and transport them to the sea. But why this commission is so important? The commission adopts recommendations related to the protection of the of the marine environment, measures to address certain pollution sources or areas of concern. And these recommendations are to be implemented by the contracting parties through their national legislations. If we get back to the main topic, phosphogypsum is a byproduct of the production of phosphoric acid, which is the most important substrate for phosphorus fertilizers. And the most economic method of the production is the wet method, which generates tons of wastes every day. Phosphogypsum is classified as a hazardous waste with high acidity and contains heavy metals. But for now, there is no possibility to manage it. So it is stored in sediment ponds or is dumped in the seas. And the biggest landfill in Poland is located in Police, the city where I work. And that's why I decided to do something with that. And the main aim of my project is to develop a method for using materials remaining from the production of phosphoric acid to building materials. Their use allows to increase the share of calcium, sodium, and silicate fraction, which are needed for the geopolymerization process. There is an idea regarding the neutralization of the acidity of this phosphogypsum and the use of alkali activators to increase the strength of the material. It can offer many additional opportunities for the development of the construction industry in the future. But the main purpose is not only the immobilization of hazardous substances, but also the commercial potential of the eco-building materials with lower production costs and lower environmental impact. But there are also some risks for the project because phosphogypsum are not used as a substitute for natural gypsum in the construction industry due to its acidity and great water absorption. But I think, and I will try to prove it, that use of alkaline activator can significantly reduce the acidity of the material and accelerate the formation of aluminum silicate bonds with calcium. So this is where spent caustic has potential. What is a spent caustic? It's a waste from purification of olefin streams. To become neutral, it is treated in wet air oxidation process, which use high temperature and really high pressure to generate the steam. So in my project, I try to prove that this stage will be unnecessary because this stream can neutralize the phosphogypsum, and both of this waste could be the new component to improve building material. So how to do this? Using of waste from the energy industry or municipal waste disposal is really known and used for increasing the aluminum silicate fraction in building products, reducing production costs and managing wastes, often hazardous to the environment, but both heavy metals and organic residues can be effectively immobilized in aluminum silicate matrices without reducing the quality of the materials or causing negative impact on the users. And I tried to prove it in my master diploma. So, but a scientific novel, it's a scientific novelty, and main challenge in this project will be use of phosphogypsum, of course, and the research methods as X-ray fluorescence and microwave plasma atomic emission spectrometry or cold vapor atomic absorption spectrometry will allow for the selection of optimal amounts of that mentioned waste in mix and meet the necessary European and Poland standards. And in addition, modern spectroscopic methods as nuclear magnetic resonance and other techniques can allow us to check mechanical properties and will confirm the quality of obtained materials. So for today, it's all from me. Thank you for your time, and if you have any question, please.
So thank you for the very nice presentation. Do we have any questions? Don't be shy. Okay, I see one on the chat. So the question is, Adriana is asking, what pollutants can still be found in the Baltic Sea? How do they change over time?
For now, the main pollutions in Baltic Sea is deposited and oxidized nitrogen and phosphorus compounds, and this is the main hazardous waste in the Baltic Sea. And because of pelletizers industry, it's changed. I can say day by day, yes, because the biggest industries in Europe are located in Poland and in Germany. So also the biggest rivers in Europe flow through these countries, and lots of agricultural areas, yes, is just sorry, I forget the word. Are washed out, yes, through this river and flew through the Baltic Sea. So, yeah.
Okay, thank you. I see that Bartosz Chojnacki wants to ask a question.
Hello, I have a question about the EU regulation in this matter. Do they exist, and if they exist, do they force us to reduce these compounds in the sea?
Yes, of course. And as I said, you can find a lot of information on the HELCOM's websites, and every year there works about a new recommendation for the European Union, how to decrease the amounts of these compounds in the Baltic Sea. So if you want to get some new information, please you can check it on this website, yes, of HELCOM. I can put the official website in the chat. So if you are interested in, you can check it.
If you can put it in chat, I will be really glad. Thank you.
Okay, no problem.
Okay, Dominika Kapuścińska, quick question because we have to continue.
Okay, I have a small question from the biological side. Do you know maybe what organism can reduce the amount of this substance in Baltic Sea? And aren't biological methods now better, less harmful to the environment and cheaper?
For me, as a I to be honest, I don't know. I try to focus on the chemical side of this problem and how to manage the waste and how to not generate this problem.
Okay, thank you.
So, sorry.
Thank you for the very nice presentation, very nice discussion.
Thank you.
Our next speaker will be Lisa Amalia from University of Debrecen. Lisa, are you here with us? Hi.
Yes, I'm here. Hi.
Okay. Can you try to share your presentation?
Okay.
Okay, perfect. We can see it.
Okay, thank you.
So the floor is yours.
Thank you. So, good morning, ladies and gentlemen. My name is Lisa Amalia. I'm a master student from the University of Debrecen, Hungary. And today I am going to present my summer field work about the experiment on the demography of the nine-spotted moth, or Amatapegea, in the Buk National Park, Hungary. So, this is the nine-spotted moth that has a very beautiful appearance for a moth, if I can say. It has a blue-black or green-black wings with the wingspans approximately about 35 to 40 millimeters. and it has a very distinctive white spots, which usually have 6 spots on the forewings and 2 or 3 spots on the hindwings, and it has a very beautiful metallic shins under the sunlight. This moth also has a quite similar appearance with Zygaena epialtes here, and as a form of a Mullerian mimicry, but some of the particular differences of these moths are that Vegia has a thin and elongated antenna with the white apex, while the epialtes no, and it has a very distinctive 2 yellow cingula at the chest and the bottom, while the epialtes only have 1 at the bottom, and Vegia spots is all white, while Zygaena have a colored spot on the forewings. This moth is also have very wide distributions around Europe, as you can see here in the map, and it vacuums mostly in the southern part of Europe, where we can find a lot of moth. While it has a very wide ecological role as an effective pollinator and also effective pest agent, unfortunately, the published study about the fundamental informations of Amatophagia, such as their demography, is still limited. So that's why here in my study, I wanted to investigate in a very small scale about the demography of Amatophagia in Baltic National Park, including estimating their population size, survival rate, the comparisons of population size and survival rate between male and female, and also to investigate whether they have restricted or unrestricted home behavior, as this is very important to understand more about their ecological role and about their populations. So this study was conducted in the Bug National Park, Hungary, near the Ripaseta village, using the mark release recapture methods. The observations done in a steepy meadow and was divided into 3 areas as shown in the pictures, and the marked release recapture was done daily from 9 to 5 by doing a constant rate walking 3 times a day. We can see the differences between the area 1, 2, and 3, where area 1 is an area that adjacent to a small path into the forest that usually hikers take to go to the forest, and it has low grass. Area 3 is adjacent to the shrubbery, and it is very close to the main roads, and it has a relatively high grass, while the area 2 are located between these 2 area 1 and 3, and it has an intermediate high grass. The results of this study, there are in total 125 moths that were marked, where almost 20% of this is female and the rest are male. And there are also 191 capture events, where almost 88% are happening in the area 1, and there is a small amount in the area 2 and a very little amount in the area 3. And if we go back to the objective of the study, first we are going to calculate the survival probability, detection probability, and proportional recruitment. And I am doing the model using mark package on R. And the top one is our best performing models, where the detection probability was influenced by time and the recruiting rate was influenced by sex. The survival rate is estimated around 0.75. It considered quite high, if I can say, and also the detections probability is 0.967, and the recruiting rate is 0.22. And using these demographic parameters, we then estimate the population size using the Joly-Saber methods, and it is quite interesting that in overall, we have an increasing trend in the whole populations of this moth, While if we separate it by sex, we can see at the top graph on the right, the female has a decreasing trend while the male has an increasing trend. And also if we compare the capturings events per day, also the recaptures events per day by sex, we can see that in all the area, the captures and recaptures is always higher in male than females. And finally, to the most interesting questions of the study, do Amatapegia have a restricted or unrestricted home range behavior? So by doing the ANOVA test, we can see that it is very obvious that they have a very restricted home range in the area 1, and it's very, very significantly different from area 2 and area 3. And also there is a moving patterns of these moths where the moths that first captured in area 1 are likely to stay there. The moths first captured in area 2 are likely to move to area 1, but the moths that captures in the area 3, the very small moth, remained there. And also it's statistically very obvious that the male moths are more active than the female moths, and it is proven by this statistical test that is very significant. So in conclusions, the study here reveals that Amatapegia has a restricted home range behavior, preferring specific areas within species heats, and the population size estimates and survival rate differs between males and females. And also this finding, even though it is a very basic study and covering a very little amount of these populations in Hungary, it is quite important to start to understand the demography of this Amatapegia, and if it is elaborated more further, it can help a lot in the conservations and the ecological role assessment of these moths. That's all, and thank you. I am open to your questions and
Thank you very much for your presentation. I see that we already have some question in the chat. So Kamil is asking, how did your interest in this species of insect begin?
Okay, so thank you for the questions, Kamil. First, we see that this moths is very, it can be easily found in Hungary, like not only in the Buk National Park to be specific, but if here in Debrecen we went to the forest in the city, we can see that this moths is can be easily found. And then when we are looking to the literature, to the published study, like to see the basic informations about this moth, it is not very well understood. There are some studies that covering the more to the physiological part of this moth, like the pheromone and something like that. The basic, very basic informations on the ecological sides is not covered yet. So I think it's very important to start doing this. And also,
thank you for your answer. So we have one more question. Can monitoring this insect provide information about the state of the environment, for example, pollution?
Okay, so from my study, as we see previously, the moths are concentrated more in the area where it is more close to the forest, and they have a tendency to avoid the area where there are a lot of cars, like near the roads. We can say yes, that we can use this as a bio indicator to indicate area which already obtain a lot of anthropological activities that doesn't feel safe to this much. So I think the short answer, yes.
Thank you for your answer, and thank you for your presentation. So I don't see any more questions. So thank you very much.
Thank you.
And this was the last presentation in this session. So the next session will start in 39 minutes, so at 10:30 UK time. So yeah, so see you after the break. Enjoy your coffee or tea, and see you.
Okay, good morning everyone. I'm Ewelina and it's great pleasure to welcome you to the sixth presentation session of Natural Science by Baltic Conference. Today we have exciting lineup of 5 presentation recordings showcasing the interesting research of our participants. After each presentation there will be time for a short Q&A session, so I ask our authors to be prepared. Let's make this session engaging and interactive by asking questions and discussions. So let's start. Our first presentation will be given by Karolina Trepczyk from University of Gdańsk. Karolina, are you with us?
Yes, I am.
Oh, so great. So I ask our technical team to play the first recording.
Hi, my name is Karolina Trepczyk and I would like to present to you a presentation titled Human 20S Proteasome Activators in the Fight Against Neurodegenerative Disease. Neurodegenerative disease, for example, Alzheimer, Parkinson, are associated with impaired functioning and gradual death of neurons. In recent years, the number of patients has increased significantly, which is why neurodegenerative diseases are considered as a plague of the 21st century. For example, it estimates that the number of patients with Alzheimer's disease will triple by 2050. This is, among others, a consequence of the increasing life expectancy. Due to the lack of effective form of treatment, the difficulty of early detection, and the cost of care, neurodegenerative diseases are a serious global socio-economic problem. A characteristic feature of neurodegenerative disease is deposition of damaged proteins, which in healthy cells are removed by proteolytic systems. For example, in Alzheimer's disease, amyloid beta and tau protein are deposited, and in Parkinson's disease, alpha-synuclein aggregates are deposited. In natural conditions, the degradation of misfolding protein structure is caused by, among others, proteasome 20S, multiprotease consisting of 28 subunits forming 4 heptameric arranged rings. Unfortunately, over the time, the enzymatic efficiency of proteasome decreases, which facilitates the development of neurodegenerative disease. Recent research shows that use of small molecule modulators to activate the proteasome can prevent the accumulation of damaged proteins and may be an effective therapeutic strategy. To improve the control of proteolysis, the 20S proteasome is additionally supported by regulators that determine the type of substrate entering to the catalytic chamber and the enzyme's activity. Currently, 3 types of proteasome activators has been identified: 19S, BLM10, and 11S. Regulators of the 20S proteasome may attach to it symmetrically or asymmetrically, forming a barrier sheeted on one or both sides. 19S, also known as P8700, is the only regulator that depends on energy from ATP. Another example of energy-independent activators is are the BLM10 and 11S activator. These activators are responsible for the digestion of abnormally structured proteins and peptides by its associated proteasome 20S. We synthesize BLM-PEP, which is 14 amino acid peptide that effectively stimulates the chymotrypsin-like activity of the human 20S proteasome. It is based on sequence of the natural activator of the 20S proteasome, the BLM10 protein. We were able to obtain a crystal structure of BLM-PEP, which yields proteasome 20S. The general localization of BLM-PEP binding site between subunit alpha 5 and alpha 6 are detailed interaction guiding BLM-PEP binding are shown in the figure. So far, a dozen of BLM-PEP modularity analogs capable of efficiently activating the proteasome has been synthesized. In order to obtain activator deprived of their main disadvantages, low proteolytic stability and unable to cross the same membrane, I introduced various unnatural modifications and attached cell permeable fragment to the TAT or 6R, consisting of 6 arginines. In this way, I obtained two groups of compounds, BLM peptomimetics with unnatural amino acid or peptoid bond introduced and an attached CPP sequence. Another group was analogs named bis-BLM because they have a duplicate C-terminal sequence. This modification was driven by our previous studies, which indicate using structural X-rate that one very efficient BLM modulator was able to bind in two adherent binding packets between subunit alpha 2, alpha 3 and alpha 3, alpha 4 of the human proteasome. The idea behind the synthesis of bis-BLM was to obtain a modulator capable of simultaneously binding in both pockets to increase the stability of the open form of the proteasome, which would allow obtaining its crystal structure. I conducted studies on the effect of the synthesized modulators on the chymotrypsin-like, trypsin-like, and caspase-like activity of the human 20S proteasome using standard fluorogenic substrate. The results obtained indicate that the change induced in the analogs compound A reduce the ability of the compound to stimulate the proteasome. In the case of compound A, C, and B analogs, a significant portion of peptidomimetics retain similar activation abilities as their parent compounds. The best peptidomimetics stimulate from 8 to 9-fold the chymotrypsin-like activity of proteasome. The activating properties of bis-BLM analog were also tested using substrate from chymotrypsin-like, trypsin-like, and caspase-like peptides. The performed test showed that bis-3 outperforms in stimulating ability the parent F compound, whose C-terminal part was duplicated in this set of modulators. Compound bis-4 showed much weaker ability to activate the 20S proteasome. The probable cause might be the lack of the N-terminal region of the compound F sequence. Its interaction may play an important role in the enzyme activation process. The best ability to activate the proteasome displayed bis-1, which is analog of compound A, and activates the proteasome as much as 12-4, 3 times more than the parent peptide. To improve the permeability through cell membrane, I synthesized compounds which include in their sequence the cell permeable fragment. The studies on effect of compounds on proteasome activity showed that the addition of CPP doesn't reduce their ability to stimulate the enzyme. On the contrary, for instance, A1 TAT activates proteasome 10 times more efficiently than the parent compound. Moreover, the obtained compounds were characterized by much greater resistance to the action of proteins present in the human cell, which was verified using the 3-chloroacetic acid protocol and chromatographic analysis on the UHPLC Nexera instrument. The content of most compounds in the sample after 30 minutes of incubation remains at the level of about 50–60%. I also tested bis-BLM compound for their stability in human serum. The most stable turned out to be bis-4. However, its influence on human 20S activity was the lowest. The second highest stability displayed bis-1 and bis-2. After 30 minutes of incubation in serum, the content was about 70%. The least stable compound turned out to be bis-3, which is probably due the fact that it doesn't have any unnatural modification in the sequence. The content of all CPP graft compounds after 30 minutes incubation in human serum was about 60%. We performed also tests for selected compounds to check the ability to stimulate the proteasome in cell lysate. The experiment showed promising results. The compounds activate the proteasome almost threefold. When tested for activity on cell lysate, bis-1 also displayed the best stimulating capacity. I conducted also studies on the activity of the compounds in the cell lysate with CPP sequence. All them of the concentration was 5 micromole and activated the proteasome about 4-fold. In the next stage of the research, I verified the ability of the compound to penetrate the cell membrane. For this proposed a synthesized analog with the NBD fluorophore attached. After 2 days of incubation, cell HEK293 compounds were added to the cells and a final concentration of 10 micromole. After 3 hours, I examined the slide under a fluorescent microscope. And here we can see images for control, A1 TAT and A16R. I conducted an MTT cytotoxicity test. After 24 hours of incubation, the compounds showed no cytotoxic effect on HEK293 cells. I performed also the PAMPA assay, which enabled to analyze the process related to the transport of the compounds through the PVDF membrane covered with a solution of the brain polar extract, imitating the blood-brain barrier. I used propranolol and TAT peptide as positive control and dopamine as a negative control. Preliminary studies show that the compounds with TAT or 6R sequence can cross the blood-brain barrier much better than the parent compound A1. Then I performed experiment to check influence of modulator on the degradation of alpha-synuclein and tau protein. Stock solution of native alpha-synuclein and tau protein were diluted with water. The sample were incubated at 37 Celsius degrees for 1.5 hours. The results were analyzed electrophoretically after loading each sample onto 12% SDS page gel. The amount of intact protein was calculated in relation to the protein incubating with the human, without the human proteasome, considered to be 100%. The results indicate that the modulator can stimulate the proteasome to degrade synuclein and tau protein. Here are the results I obtained during my internship at the University of Helsinki. For this experiment, I used hippocampal cells. Cell was isolated from pregnant mouse embryos. The entire experiment was carried out as shown in the diagram. In the day in vitro 8, I made PFF treatment. In day in vitro 15, I made fixation by 4% PFA. And after 20 minutes incubation, I started staining cells with standard protocol. Here we have the results for this experiment. Conclusion is that the compounds do not exhibit high cytotoxicity. The compounds reduce alpha-synuclein aggregates in hippocampal cells, and the dependence of the effects on the reduction of aggregates of the concentration of the compounds is visible. Here we have fluorescent images. I use primary antibody rabbit monoclonal antiphosphoserine alpha-synuclein and the mouse anti-neurons, and then unstained cells with secondary antibodies, Danki anti-rabbit Alexa Fluor 488 and Danki anti-mouse Alexa Fluor 647 and DAPI. Here are the images when we can observe the reduction of alpha-synuclein aggregates with increasing concentration of the activator. And thank you for your attention.
Thank you, Karolina, for your presentation. Your research findings are fascinating and showing a lot of work and many days spent in the lab. So now the floor is open for questions and discussion.
Thank you very much.
Oh, there is a question from Wojciech, please.
Hi, thank you for your presentation. That was inspirational for me. I have a question. Because I understood that you modified proteasome with this peptide in vitro, and you checked it also in cells. But how can you check it in vivo in mice? How can you modify this proteasome, or you can just add this peptide, inject this peptide intravenous to make it better? And how can you check whether this peptide is not degraded? Maybe in vivo it's not so efficient because it can be easily degraded. I understood that this modification is more efficient when you modify it in vitro, yes? So how can you explain for me more?
Okay, so for beginning, I didn't modified proteasome. We isolated proteasome from human blood. I synthesized peptidomimetic activator, which influence for proteasome and then activate proteasome to for first better degradation protein which are connected with neurodegenerative disease, for example, Alzheimer and Parkinson. And for example, in case about experiment with mouse, we isolate cells from embryos mouse. They also have a proteasome, and then we added PFF to cells, mouse cells, which caused aggregates which are connection with Parkinson disease, and then we check what happened when I added my compound, which influence or for proteasome, and that my activators can make proteasome more effective in degradation of this, we can say, bad protein.
I understand now. Because firstly, I thought that you co-synthesized proteasome in vitro with this modification, but it's not like that. It's you added the peptide to the isolated cells. Yes, so it can work. So you can process the further step on mice.
Yes.
Because it's efficient enough to proceed.
Yeah.
Okay, thank you for the discussion. Karolina, we are out of time, but there is also one question for you on chat, so I ask you to answer for this question on chat. And we have to move to the next presentation, which will be given by Magdalena Górniewicz from Jagiellonian University.
Welcome. My name is Magdalena Górniewicz and I would like to make my presentation which presents the results of my own work on the topic nanocarriers based on chondroitin sulfate nanocapsules for delivery of drugs and nutraceuticals. Polymer nanoparticles are of great importance in the preparation of drug delivery systems. They are used to improve various pharmacological and therapeutic properties of conventional drugs, as well as to provide sustained drug release and minimize toxicity by reducing accumulation. Biopolymers, such as glycosaminoglycans, are being intensively studied to develop nanoscale drug delivery systems for therapeutic purposes in the treatment of various diseases. This group includes compounds such as hyaluronic acid and chondroitin sulfate. Selected hydrophilic polymers can be grafted with hydrophobic groups, thus obtaining amphiphilic polymers. Hydrophobically modified chondroitin sulfate dispersed in an aqueous environment assemble into nanometric micelle-like structures with chondroitin sulfate chains on the outside and hydrophobic groups forming the cores. However, using them to prepare polymer nanocapsules with an oil core may prove to be a more efficient way to develop delivery systems for bioactive substances. The polymer coating provides stability and protection for the oil core, which may be beneficial for active substances, especially those susceptible to degradation in the external environment. Additionally, the polymer coating can enable controlled release of active substances, which is important for many applications such as drug delivery. Polymers can be well tolerated by the body and can be compatible with various types of active substances. Polymers can be functionalized to additionally introduce various properties such as the ability to target the delivery of active substances to specific places in the body. The motivation for my research was to obtain polymer nanocapsules with an oil core based on hydrophobically modified chondroitin sulfate and to assess their physicochemical and biological properties such as cytotoxicity. Dispersing a hydrophobically modified polymer in water can lead to the formation of polymer micelles. A polymer micelle is an aggregate of polymer molecules in which the hydrophobic part of the polymers faces inwards and the hydrophilic part faces outwards in contact with water. This system allows for the creation of a stable dispersion of the hydrophobic polymer in an aqueous medium. When a hydrophobic polymer is introduced into water, its molecules tend to clump together to avoid contact with the water. However, due to the presence of hydrophobic groups, some parts of the polymer molecules face outwards, which allows them to interact with water molecules. As a result of this process, polymer micelles are created in which the hydrophobic parts of the polymer are hidden inside and the hydrophilic parts are directed outside, surrounded by water molecules. Polymer nanocapsules were obtained by sonication-assisted emulsification of the oil phase in a solution of amphiphilic polysaccharides. Hydrophobically modified polymers are able to form micellar structures above the critical aggregation concentration.
Fluorescence measurements using diphenylohexatriene as a molecular probe were used to investigate the aggregation of hydrophobically modified chondroitin sulfate in an aqueous medium. The intensity of diphenylohexatriene fluorescence increased with the increase in polymer concentration in the system, which is related to the transition of fluorophore molecules to hydrophobic domains created by alkyl groups of the obtained derivatives. The experimental results showed that as the degree of polymer substitution increased, the critical aggregation concentration value of the polymer tended to decrease. This phenomenon may be due to the fact that greater grafting of alkyl groups on the amphiphilic polymer increases the hydrophobicity of the polymer and promotes the self-assembly of amphiphilic polymers. The size of objects formed in polymer dispersions at concentration above critical aggregation concentration was determined using light scattering measurements. As the degree of substitution increased, the size of the aggregates decreased, probably due to the increased attraction between hydrophobic groups that tend to avoid contact with water. As a result, aggregates formed by polymers with higher alkyl group substitution should have a more compact structure. Zeta potential is an important parameter for predicting the stability of dispersion systems. The particles had relatively high negative zeta potential. This high negative charge is due to the presence of ionized carboxyl groups and sulfate groups. However, the potential values increased with increasing degree of substitution, which is probably related to the conversion of negatively charged carboxyl groups to neutral amide groups. The obtained nanocapsules loaded with GT oil or vitamin E were examined for their physicochemical properties. The sizes tested using the dynamic light scattering method are in the range of 300 to 500 nanometer. Adding an oil core to the capsule increases the volume, which leads to larger overall nanocapsule sizes. An oil core may be needed to accommodate more active substance. The increased size of the nanocapsules may affect the release rate of active substances from the oil core. Larger capsules may have less surface area to be covered by the polymer layer, which may slow down to the release of active substances. This may be desirable for controlled release of active substances. A high negative zeta potential indicates the presence of a large amount of negative charges on the surface of the particles, which stabilize the dispersion, preventing agglomeration of aggregation of the particles. As a result, the particles remain evenly dispersed in the solution. Dispersion stability due to the high negative zeta potential can increase to bioavailability of oil core polymer particles, making them easier to be absorbed by the body for medical or pharmaceutical applications. Cryo-TEM is a powerful imaging technique that can provide detailed information on the structure and morphology of nanocapsules. The sizes of nanoparticles obtained using cryo-TEM microscopy are smaller than those obtained using dynamic light scattering and range from 20 to 250 nanometers. In dynamic light scattering, the hydrodynamic size of particles in solution is measured, which includes not only the particle itself but also the hydration layer surrounding it. Interaction between particles in solution, such as aggregation, can influence dynamic light scattering results, leading to an overestimation of particle sizes. In the case of cryo-TEM, the particles are stabilized in a liquid state, which reduces the tendency to aggregate. Micrographs show the spherical shape of the nanocapsules surrounded by a polymer layer. Cytotoxicity of polycations is a very important issue in therapeutics in the context of their use in delivery systems. Polymer nanocapsules loaded with GT oil or vitamin E were tested for their effects on cell viability of human spleen tissue using the MTT cytotoxicity assay. The viability of cells incubated for 1 and 5 days with nanocapsules is shown on the slide, respectively. The results clearly indicate that polymers not loaded with an oil core show increased toxicity compared to nanocapsules with GT oil or vitamin E. The polymer substitute with oleoylamine shows lower toxicity, and the addition of vitamin E additionally supports cell proliferation. This indicated that nanocapsules can be a carrier of biologically active substances such as drugs or vitamins that can influence cellular processes. If these substances are beneficial to cells, nanocapsules can improve cell viability by delivering these substances in a controlled manner. Nanoemulsions based on oil core nanocapsules are capable of being effective in transporting various lipophilic bioactives. This study focused on the preparation and characterization of nanocapsules containing chondroitin sulfate-based shells and liquid oil cores. To accomplish this, 2 hydrophobic derivatives of chondroitin sulfate were synthesized by attaching octadecyl or oleal chains, and then the chondroitin sulfate-based nanocapsules were created by emulsifying triglyceride oils within a dispersion of hydrophobically modified chondroitin sulfates using sonication. Using dynamic like scattering and cryotherm methods, it was possible to determine the sizes and spherical shape of core shell nanoparticles. The cytotoxicity of chondroitin sulfate hydrophobic derivatives and chondroitin sulfate-based nanocapsules was assessed using primary human skin fibroblasts. This allowed to demonstrate that the use of hydrophobic polymer derivatives as coatings of oil core nanocapsules reduces cytotoxicity of chondroitin sulfate derivatives. Chondroitin sulfate-based nanocapsules showed effective encapsulation of hydrophobic compounds, suggesting their potential as carriers for lipophilic bioactives. Thank you for your attention.
Thank you, Magda, for sharing with us your research findings. We still are out of time, so maybe one short question to Magda. So yes, Aleksandra?
Okay, I have a question. How were Nile red samples prepared, and what information do the microscope images provide?
Thank you for your question. To assess the intracellular uptake of chondroitin sulfate-coated nanocapsules by cells, their oily core was stained with Nile red. The cells were incubated with fluorescently labeled nanocapsules for 1 day and imaged by confocal laser scanning microscopy. The cells exposed to Nile red loaded nanocapsules showed red fluorescence at the cytoplasmic level. And it can be assumed that nanocapsules enter the cell and localize near the cell nuclei. Based on these observations, it can be concluded that the nanocapsules were effectively internalized by both cell types.
Thank you. There is also one question on chat, and I ask you, Magdalena, to answer this question also on chat.
Okay, okay. Thank you very much.
Thank you once again. And our next presentation is made by Anna Pogorzelska from National Medicine Institute. So I ask our, yeah, it's working.
Hello everyone, my name is Anna Pogorzelska and I'm doing a PhD within Medical Sciences at National Medicine Institute in Warsaw under the supervision of Katarzyna Wiktorska from Warsaw University of Life Sciences and Małgorzata Milczarek from National Medicine Institute. Today I want to present some of my latest results regarding the role of dietary doses of sulforaphane in the treatment of triple-negative breast cancer, the insights from in vivo and in vitro studies. Starting with a few words of introduction into the background of the study. Breast cancer is the most common malignant tumor in the world. It is a heterogeneous disease in which genetic and environmental factors are involved. Based on both molecular and histological evidence, breast cancer could be categorized into three groups: breast cancer expressing hormone receptor, breast cancer expressing human epidermal growth factor receptor 2, and the triple-negative breast cancer. The last one, due to lack of receptors, is the most aggressive one, and treatment is the most challenging in comparison to other groups of breast cancer. The standard treatment for this group is still mainly chemotherapy, and the prognosis is poor. Many phytochemicals exhibit a non-monotonic dose concentration response, termed biphasic dose response, and are classified as hormetic compounds. That means they produce biologically opposing effects at different doses. Most commonly, they have a stimulatory effect at low concentrations, whereas they show an inhibitory effect at high concentrations, as we can see on the graph on the right. One of such hormetic compounds is a phytochemical sulforaphane. It is an isothiocyanate whose precursor glucoraphanin is found in brassica vegetables. It shows chemopreventive and also anti-cancer effects. The purpose of this study is to test the role of dietary low dose of sulforaphane on tumor development, proliferation, and migration of the triple-negative breast cancer cells in the in vivo and in vitro model. We have conducted an in vivo experiment using a triple-negative breast cancer mouse model. A tumor was induced in biopsy mice with 41 cells, and the mice were administered with a low dose of sulforaphane and water as a control 3 times at weekly intervals. The graph shows the kinetics of tumor growth and the calculated inhibition of tumor growth by the action of the sulforaphane. On the first days of the experiment, sulforaphane inhibited the tumor growth at about 25 to 31%. Later, the effect decreased to about 13 to 20%. As the next step, histological evaluation of the tumor sections was performed. Tumor sections were stained and the mitotic index was determined, indicating the cell's proliferation potentials. Mitotic index in the sulforaphane-treated tumor was significantly lower compared to the non-treated control group, as we can see on the graph C. So a notable decrease in the proliferating potential of tumor cells after sulforaphane treatment was observed. Furthermore, hematoxylin and eosin staining after sulforaphane treatment revealed reduced size of areas of necrosis, reduced intensity of inflammatory cell infiltration, and change in their type, decrease in lymphocytes and histiocytes, and increase in the proportion of neutrophil granulocytes. There were also no features of anaplastic foci, showing less malignant type, in contrast to the non-treated group, as we can see on a graph F. To further investigate the sulforaphane effect on the malignancy of the tumor, the number of metastases was calculated in the lungs at the end of the experiment. The graph shows the mean number of metastases in lungs, which was lower after sulforaphane treatment. 34 counts for the control group versus the 23 counts per mouse after the sulforaphane treatment. The last analysis performed from an in vivo experiment was blood morphology analysis, which revealed a lower total leukocyte number and specifically a lower number of granulocytes, but a higher number of platelet compared to the control. There was also a significant increase in the percentage of monocytes compared to the control. We have also conducted in vitro studies where we exploit MDA-MB231 human triple-negative breast cancer cell line in a normal 2D monoculture and also a 3D spheroid model. The cytotoxicity on a 2D model showed that sulforaphane acted hormetically, slightly boosted proliferation of the cells at the lowest concentration tested, but also effectively inhibited tumor cell growth at higher concentrations as shown on the graph A. On the other graph B, we can see that sulforaphane showed small to moderate cytotoxicity on tumor cells, forming as spheroids. Sulforaphane did not show a hormetic action here. At low concentrations, it did not boost the proliferation of cells forming a spheroid. We have also performed an FDA-PI staining of spheroids, which showed differences in live dead cells proportion after sulforaphane treatment. Live cells are stained green with FDA and dead ones red with PI. Representative photos are shown on the graph C, where sulforaphane doses are growing from left side to the right. At small concentrations of sulforaphane, spheroids show small necrotic cores and high viability in the outer spheroid layer. At higher concentrations, starting from 5 micromolar, the viability of cells was significantly lower, and the number of dead cells and necrotic cores was growing. The morphology of spheroids has also changed. With higher concentrations, spheroids were more loosely aggregated and started to lose their circularity. To further assess the influence of sulforaphane on cell migration, a wound healing assay was performed. This assay was conducted to explore the ability of this anti-cancer compound to impact the migration and formation of new cell-cell interactions, and the results show susceptibility to metastasis formation. In the cells cultured in 2D monolayer on the left side of the graph, only after the highest dose of sulforaphane used, the migration was significantly inhibited and in a smaller manner after the medium dose. A wound healing assay was also performed on the monolayer culture of cells derived from 3D spheroids to investigate whether the 3D culture affects cell invasion and migration and better mimics the in vivo conditions. Results are shown on the right side of the graph. Spheroid-derived cells have not shown a higher migration rate compared to the 2D cells, albeit the higher concentration of sulforaphane inhibited the wound healing in a greater manner than in the 2D cultured cells, reducing the ability to metastasis formation. The inhibition of tumor cell migration was also observed after 48 hours on cells treated with lower doses of sulforaphane, which was not observed in 2D cultured cells. Summarizing the presented results, sulforaphane at low concentrations led to the reduction of tumor volume, together with decreased mitotic activity and reduction of metastasis in animal triple-negative breast cancer model. This is consistent with the observed impaired motility of cells from sulforaphane-treated spheroids. Moreover, the mobilization of neutrophils to the primary tumor, together with a reduction in the blood circulating granulocytes, collectively contributed to the tumor eradication and the reduction in the extent of lung metastasis. Considering that anti-proliferating and anti-metastatic activities were evident in the 3D in vitro and in vivo models, but not in the 2D in vitro model, the results strongly indicate that low sulforaphane concentration affects not only directly cancer cell proliferation, but also other components of tumor microenvironment, such as immune system. Here's the literature which I used to prepare this presentation, and I want to mention that this study was partially funded by the National Science Center from my Podium grant. Thank you for your attention, and I'm open for any questions.
Thank you, Anna, for sharing results of your project, which deals with a very significant topic. I encourage everyone to take this opportunity to ask questions or exchange ideas. I believe there is a question on the chat, so I will read it. So, do you consider to check the potential of other plant-derived substances in breast cancer-related research?
We are focused on sulforaphane right now. We are also conducting other research which we
combine sulforaphane with other chemotherapeutics. So right now we focus only on sulforaphane, but my colleagues are also checking other plant-based substances, for example, chlorophyll or something like that. But these studies are on the early stages right now. Right now I can share with you the results of sulforaphane action on triple-negative breast cancer.
Thank you for your answer. We still have time for one more question, so maybe somebody wants to ask something. Anna. Okay, if there is no questions, so let's move to the fourth presentation, which will be given by Anna Sendera from Medical College of Rzeszów University.
Did you know that stem cell therapy may help with the variety of diseases and conditions that are currently incurable? Personally, I feel so hopeful for future medicine. Hi, my name is Anna Sendera, and I am currently working on my PhD project exploring the possibility of mesenchymal stem cell use in regenerative medicine. I would like to talk about stem cell therapy and discuss new approach of preconditioning of mesenchymal stem cells with low-frequency electromagnetic fields. But before we go further in the topic, I would like to shortly introduce you all to the basics of stem cells. So what are the stem cells? Stem cells are undifferentiated cells with the potential for multidirectional differentiation and self-renewal. By self-renewal, we mean dividing into more stem cells, while by differentiation, we mean changing stem cells into cell types such as red blood cells or chondrocytes, so cells more specialized in specific functions. However, stem cells can have a different potential for differentiation depending on the origin. In stem cell therapy, multipotent and pluripotent stem cells are being considered. Multipotent cells are able to differentiate into numerous but closely related cell types within one lineage. An example of multipotent stem cells are hematopoietic stem cells and mesenchymal stem cells, which can be isolated from adult tissues and are called adult or somatic stem cells. In turn, pluripotent stem cells are able to differentiate into any of cell type of the body. They can be obtained from the inner cell mass of blastocysts, then we mean embryonic stem cells, or can be obtained by reprogramming of somatic cells, and then we mean induced pluripotent stem cells. Currently, of the greatest interest for use in therapy are adult stem cells, especially multipotent mesenchymal stem cells, which have the potential to be used for skin regeneration, autoimmune diseases, bone regeneration, and more. The therapeutic potential of mesenchymal stem cells is based on the ability to differentiate into tissue-specific cells, contributing to tissue regeneration, but it's not only limited to the differentiation process. Mesenchymal stem cells have a very rich secretome, which consists of many active biomolecules with immunomodulatory, pro-angiogenic, revitalizing, and neurotrophic properties. Mesenchymal stem cells can practically be isolated from various human tissues, such as the umbilical cord, so Wharton's jelly, umbilical cord blood, placenta or dental pulp, but most often, cell therapy considers the use of mesenchymal stem cells isolated from bone marrow and adipose tissue. Apart from promising therapeutic benefits, the use of mesenchymal stem cells in cell therapy has its limitations, such as low level of cell survival, as well as difficulties in predisposing and monitoring cells after transplantation, and also the risk of their spontaneous differentiation in an undesirable direction, and the possibility of the occurrence of chromosomal aberrations. To let go of these limitations, instead of transplantation of whole mesenchymal stem cells, a strategy of using only the secretome is being considered in a therapy called stem cell-free therapy. Also, preconditioning stem cells with biochemical and physical inducers and even genetic modifications are being considered. It can help to increase cells' adaptive capabilities and their natural biological abilities before administration to the patient. One of the physical factors that can control cellular fate, considered by researchers for preconditioning strategy, is the electromagnetic field. It can be grouped into two categories, which are based on its frequency: non-ionizing and ionizing electromagnetic fields. In the context of regenerative medicine, most of the research papers that have published the positive effects of electromagnetic fields on mesenchymal stem cells have tested static and low-frequency electromagnetic fields up to 100 Hz, showing that non-ionizing electromagnetic fields can be a useful tool in stem cell therapy, among others for bone and cartilage repair or wound healing. In fact, electromagnetic fields have been shown to impact mesenchymal stem cell biology by influencing proliferation, differentiation, cell cycle progression, metabolism, and cytokine and growth factor secretion. The exact mechanism through which electromagnetic fields act on mesenchymal stem cells is not yet known, although it's being intensively studied. It is currently known that electromagnetic fields affect the ion flux in the cell, which can cause a series of subsequent changes and a biological response, both positive and also negative. Thus, electromagnetic fields can determine stem cell fate decisions such as differentiation, self-death, stem cells maintenance, or neoplastic transformation. However, it is important to mention that it is depending on the parameters and duration of electromagnetic field stimulation. For example, many studies have shown that electromagnetic field can influence proliferation and increase it. However, few studies showed that there is no effect or even proliferation was inhibited. However, inhibition of proliferation has been shown only at high magnetic flux density of electromagnetic field. Moreover, electromagnetic fields affect the cell cycle and direct the cells into G2M phases and enhance cellular progression from G1 to S phase. Frequency 50 Hz is most commonly tested, and you can observe at the presented graphs results from my lab that cell growth and proliferation is enhanced in electromagnetic fields group, which have been also shown by many other researchers. It is worth noting here that low-frequency electromagnetic field does not impact the viability and has no thermal effect on cells. Electromagnetic fields can also affect mitochondria. It is important to point out here that mesenchymal stem cells are characterized by low mitochondrial activity unless they go under differentiation, which requires a high energy demand. In response to electromagnetic field, mitochondria can initiate dynamic processes such as mitochondrial fusion and migration, which you can observe in the presented microscopic features that I have collected. Other research groups have also shown that electromagnetic fields can cause changes in mitochondrial DNA copy number and increase the energy metabolism of mesenchymal stem cells. Electromagnetic field can also enhance the regenerative properties of mesenchymal stem cells by modulating specific protein secretion like cytokines or growth factors, enhancing tissue regeneration and cell differentiation. On the left side of the slide, you can see graphs showing mean concentration values of secreted growth factors by adipose-derived stem cells after electromagnetic field stimulation with a frequency of 50 Hz after 24, 48, and 72 hours. Results show that electromagnetic fields with these parameters can increase growth factor secretion efficiently, mostly after 48 hours. However, only for fibroblast growth factor 2 changes were statistically significant. The electromagnetic field can also enhance mesenchymal stem cell differentiation potential. Clinically, most interest is focused on the chondrogenesis and osteogenesis of mesenchymal stem cells, but also neurogenesis is being widely studied. In fact, the electromagnetic field can modulate stem cell fate and determine their differentiation by affecting cell-cell communication, by influencing changes in cell compounds, calcium influx, and reactive oxygen species formation. On the right side of the slide, you can see results of relative genes expression after 24 and 48 hours of electromagnetic field stimulation, showing changes in osteogenic, chondrogenic, and neural markers expression. Safety and effectiveness are mandatory criteria for introducing stem cell-based therapies as a standard, but these require validated clinical trials results. If you are wondering whether the use of mesenchymal stem cells preconditioning with electromagnetic field is currently clinically tested, the answer is yes. Currently, 2 clinical trials are registered in the Worldwide Clinical Trials Database, which evaluates the effect of this therapeutic approach. The published results showed that treatment with mesenchymal stem cells and electromagnetic fields can be effective in toxic optic neuropathy and can prevent permanent blindness, as well as can significantly slow the progression of the retinitis pigmentosa. So let's summarize the presented information on the influence of low-frequency electromagnetic fields on the preconditioning of mesenchymal stem cells and the perspective for stem cell therapy. First, the vast majority of in vitro, in vivo, and clinical studies show the positive biological effect of electromagnetic fields on mesenchymal stem cells. It can be significant in increasing the effectiveness of stem cell therapy and stem cell-free therapy by increasing the differentiating potential of mesenchymal stem cells and modulating their secretome. However, the effect of electromagnetic fields on mesenchymal stem cells can be different depending on the parameters and duration of electromagnetic field stimulation. Importantly, the use of low-frequency electromagnetic field in mesenchymal stem cell preconditioning may be an effective approach to overcome the limitations of mesenchymal stem cell therapy. The use of electromagnetic field may prove to be a relatively cheap, quick, and controlled method of preconditioning mesenchymal stem cells in the production of an advanced therapy medical product, and time is sometimes a very important element in achieving a positive treatment effect. Nevertheless, it is crucial to adjust the electromagnetic field's parameters and stimulation time that demonstrate the maximum therapeutic effect while minimizing side effects. Thank you for your time. Delighted to answer any questions you may have about this topic. Feel free to ask now, or you can contact me after the conference session.
I appreciate, Anna, that you share your research with us. Now let's dive deeper into the topic by inviting questions from the audience. Professor Wiktorska, please.
Good morning, everybody. Thank you for this very nice lecture or a presentation. At the end, you said that this kind of preconditioning could decrease the side effects of the stem cells therapy, but does this procedure has its own side effects or any threat to the health?
Thank you for your question. This procedure with preconditioning is relatively considered as non-harmful for human health. Indeed, there is a statement that electromagnetic field can have a harmful effect of human health, but it's considered more for frequencies like radio frequencies, not low frequencies.
Okay, thank you very much for your answer.
Thank you.
And there is another question on the chat. So, does low-frequency electromagnetic field affect other cells than mesenchymal stem cells?
Yes, it can affect other cells than stem cells because electromagnetic fields in general affect biological structures in cells. So, I can't provide you an exact example, but I'm sure it does.
Yes. Okay, thank you for the discussion. And now it's time for our last presentation in this session. So I ask to play recording of presentation made by Aleksandra Makiej from Poznań University of Technology.
Dear STEAM guests, welcome to my presentation on innovations in antimicrobial hydrogel development for enhanced wound care. This research project was partly done under the STER program during my research stay at the University of Technology, Sydney in Australia. Control release is a worldwide important issue in pharmaceutical technology. Targeted drug delivery systems with control release of drugs for antimicrobial resistance and shortage AMR are urgently needed, as AMR is nowadays called a global crisis, causing millions of invasive infections each year. Therefore, it is crucial to increase research into new drug delivery materials as well as on new modified antibiotic formulations. This would contribute to the possibility of reducing the doses of bioactive substances which imply to be more effectively released to the targeted site when encapsulated within the novelty material applied as drug delivery system. Around 70% of bacteria causing wound infections are currently resistant to at least one antibiotic. This proliferation of resistant strains poses a pandemic threat to human health, resulting in over 700,000 deaths yearly, a number that is projected to escalate to 10 million annually by 2050. A wound is a disruption in the anatomical structure and function of the skin, categorized as acute or chronic. Causes include trauma, burns, diabetes, genetic disorders, or surgery, posing a significant economic burden to healthcare systems. The aging population, coupled with rising chronic diseases like diabetes and obesity, has heightened the prevalence of chronic wounds. In the United States alone, over 2% of the population experience chronic wounds during their lifetimes, resulting in annual costs exceeding $25 billion. Acute wound healing occurs through 4 overlapping phases: coagulation, inflammation, proliferation, and remodeling. Despite this, many molecular mechanisms remain poorly understood. Factors such as size, depth, and severity of injury significantly influence the healing process. Disruption or deregulation of any phase can lead to the development of chronic wounds. Bacterial infection poses a significant challenge to wound healing, as compromised skin provides an entry point for microbes. Prompt initiation of the healing process is crucial to restore skin integrity and minimize infection risk. The table on this slide highlights microbial species commonly found in acute and chronic wounds. Gram-positive bacteria like Staphylococcus aureus typically appear in the early stages of infection, while gram-negative ones, such as Pseudomonas aeruginosa, emerge in later stages. Bacterial penetration into wounds creates an optimal environment for pathogen growth supported by moisture, temperature, and nutrients. This invasion can impede healing through various mechanisms. Bacteria consume tissue nutrients and oxygen while producing endotoxins, leading to wound site expansion, hypoxia, vascular occlusion, and tissue necrosis. Critical bacterial colonization and infections can significantly delay healing and escalate to life-threatening conditions like sepsis or multi-organ failure, depending on bacterial load severity. Ancient civilizations like the Egyptians around 2000 before Christ pioneered wound management, employing three main steps: cleansing wound, grafting plasters, and bandaging. They introduced innovations like honey application and adhesive dressings. Today, wound dressings primarily consist of plasters or bandages, but advancements in material science have led to the development of so-called smart wound dressings. These modern innovations offer promising potential for enhanced wound care management by fostering an environment conducive to accelerated healing. Wound dressings serve as temporary protection for wounds while promoting healing and skin regeneration by maintaining a moist antibacterial environment. The complexity of chronic wounds necessitates the development of advanced dressings capable of actively monitoring wound progress. Hydrogel materials, propelled by advancements in polymer science and material fabrication, offer promise in this regard. The high water content fosters proper wound moisture, while their ability to load and release bioactive molecules makes them effective for treating chronic non-healing wounds. Smart hydrogel dressings achieve their intelligence through the incorporation of physiochemical stimuli-responsive components within the polymer network. These components actively interact with the wound environment, altering properties like swelling, deswelling, and mechanical stiffness in response to stimuli. To enhance medical efficacy, drugs and pharmaceutical compounds can be loaded into the polymer matrix for controlled localized release. This can be achieved through entrapment, where drugs are encapsulated during polymer gelation, offering sustained release and protection, or via permeation, which involves passive saturation of the polymer matrix over time but lacks control over release profiles. Let's now explore the importance of key markers for assessing wound status. So first one is pH. Elevated pH levels found in over 80% of chronic wounds often indicate infection. Chronic wounds typically colonized with environmental pathogens exhibit higher pH values up to 10, promoting bacterial growth. The second one is temperature. So infection and metabolic changes can elevate wound temperature by at least 1.11 degrees Celsius. Extreme hypothermia correlates with poor wound healing and increased infection risk. Here you can see our idea of smart hydrogel with 2 bioactive ingredients incorporated. One of the ingredients is derived from a plant and acts as a bioenhancer to the other one, currently available on the pharmaceutical market. Herbal medicines have a rich history in folk medicine for accelerating wound healing dating back to ancient times. Traditional uses of plant-based extracts highlight their potential to enhance tissue regeneration through various mechanisms. Many of these herbs have documented efficacy and known mechanism of action, making them valuable sources of alternative medicinal compounds for managing diseases, including wound healing. Adult wounds often heal slowly and leave scars, contrasting with the rapid and scarless healing observed in human embryonic skin wounds. This phenomenon is attributed to the closure of wound gaps in the embryonic epidermis through the contraction of actin cable resembling a drawstring bag, as illustrated in Figure 12. Drawing inspiration from this natural process, in our design of hydrogel, we use a polymer that is known for its excellent thermoresponsive self-contraction property. Leveraging this thermoresponsive property, our hydrogel dressings assist wound closure in adults. The widespread application of our base polymers stems from its lower critical solution temperature of approximately human body temperature. This means the material transits from a solution to a gel state at physiological temperatures in aqueous solutions. This transition occurs as the random coil polymer chain conformation shifts to a globular structure with increasing temperature. Our novel hydrogel, consisting of a base polymer mentioned previously, modified with polysaccharide, was prepared by radical polymerization using a response surface methodology. This methodology was based on a three-level, three-variable box-band design that was used to optimize the loading of polysaccharide in formulation and two active pharmaceutical ingredients, here called in shortage API, into already selected synthesis parameters. Influences of these three variables, that is, the mass to volume of those ingredients on releasing API from hydrogel formulations, were here evaluated. Tests of release were done in 3 different pH conditions, and then also the selected formulations were tested on microbes to prove their effectivity and applicability. The first microbiological test performed was a disc diffusion test, the steps of which you can see on the left-hand side. And the second microbiological test helped us to assess the metabolic activity of microbes at previously selected different pH levels, which you can see on the right-hand side. From the results obtained from the release test, we can see confirmation of our assumption that the hydrogel we modify will gain an additional pH responsive function. We wanted to achieve an increased release of API into the alkaline environment, marked with blue line, which was achieved for gradual release of the antibiotic, shown in upper row graphs. However, in the case of the presented results in 2 out of 3 loading possibilities, the added herbal bioenhancer was released best at the pH of 6, showed with orange line in bottom row of graphs. The results obtained from the antibiogram disc test indicate significant zone of growth inhibition of both tested strains of microbes. The results given are the radius of spherical inhibition zones. Furthermore, in the second test with an indicator, for 1 out of 3 selected hydrogel presented here, it was also possible to obtain extremely promising growth inhibition of both strains in all selected pH environments, including the alkaline environment that can be found in a wind environment, which is the most favorable for the development of selected microbes, and which is the environment in which it is the most difficult to combat them. Our formulation reduced pathogen growth even in this environment, as shown in the rightmost column graph. Here are the references that have helped me to prepare this presentation. And at the end, I want to thank you for your kind attention, Also, I would like to add additional thanks to the STER program from the Polish National Agency for Academic Exchange for enabling my research internships at the UTS in Australia, where a prototype of the presented hydrogel was created under the supervision of extremely qualified scientific staff.
Thank you, Alexandra. Your presentation shed light on an important aspect of the field. So let's continue the dialogue by inviting questions from the audience. Okay, Bartosz Chojnacki have a question, so please.
Yes, hello. I would like to ask, can you elaborate a bit more about significance of use of the plant-derived material and substances?
Do you want to hear like more exact details about the ingredients that we use to formulate this platform? Yeah, is it right?
Yes, especially those which were derived from the plants.
All right, so I can say you not the exact type that we use here because we would like to have a patent for this project. So I'm not going into the details exact of this substance, but I can tell you that it was from the group of saponines that we are just studying in our research group. And this one was the pure compound, so it was also testified firstly on human cell lines that we know it has no cytotoxic effect also in the human culture lines. So if you want to know more, I can tell you the name of this exact one, but I can tell you also more about saponines. So in previous years, they were considered as cytotoxic, but if you are dealing with pure compounds and in exact concentrations, then you can still get the effect of bioenhancing, the effects of other drugs like antibiotics, and do not harm any human cells.
Okay, thank you very much. I've asked because I'm interested in use of the plant-derived substances in the medical application, so that's why I asked.
I also have one question. I'm just wondering if can bacteria become resistant to the substances which you are using in these hydrogels, like antibiotics resistance, or there is no such mechanism?
This is the problem that I wanted to deal at the first year of my studies, but then it was like too complicated because then if you are going into fighting with antimicrobial resistance, then you are on dealing on the genome level. So it's a little bit too outside of the scope of my thesis, but then I am dealing with the making antibiotic that is current on the market more available to penetrate the bacteria. So here I am dealing with getting more efficient substances if I'm combining these two, like plant-derived substance and with the current available drugs that are antimicrobial ones, and packing them into the responsive hydrogel materials, making the platform that will deliver them to the specific site of infection.
Okay, thank you for your answer and good luck with your project. And this was the last presentation of the 6th presentation session of Natural Science Baltic Conference. Now we will have 15 minutes break or 12 minutes break till 12 p.m. So after the short break, we will have next 2 presentation sessions followed by poster sessions. So see you there. Bye.
After the break.
My name is Tom. I'll be the host of today's session. Right. So the next speaker would be the Catarina Fernandes from the University of Coimbra. So if you're ready, let's go and listen to the presentation.
Hello everyone, my name is Catarina Fernandes. I am a PhD student in chemical engineering at University of Coimbra, Portugal. Today I'm excited to share with you a part of my PhD thesis which focuses on the valorization of agroforestry residues, particularly lignin, for the development of sustainable hair care formulations. Specifically, today my presentation will focus on cationic lignin derivatives as natural ingredients for air conditioners, highlighting our recent progress and results in the chemical modification of lignin. And what has motivated this work? We all know that hair is very important because it has a function in scalp protection and it helps in thermoregulation. For humans, it also has a very important role on how people perceive each other and themselves, having a direct impact on people's social image and consequently on their self-esteem. Based on this, the demand for effective hair care products is considerable. However, to formulate these products effectively, it's crucial to understand the structure and degradation mechanisms of hair. So what is hair? Hair is a fibrous biomaterial that is composed of proteins, lipids, water, and other minor compounds such as pigments, with proteins being the main component of hair that can account for up to 95% of the total hair weight. At the surface, the hair shaft is covered by a lipidic layer that is called F layer. This layer is responsible for the hydrophobic nature of an healthy hair, and this is what causes the decrease in friction between hair fibers and of the frizz effect, and also contributes for a shiny hair. But because the hair is constantly exposed to various degradation factors, such as the mechanical weathering when brushing our hairs or the UV radiation caused by sun exposure, the surface of the hair can get degraded, and this protective layer gets removed. At the end, this naturally hydrophobic hair surface becomes more and more hydrophilic, presenting a negative density charged surface. And this is what causes the hair to have this flyaway and dry appearance. To overcome these undesired effects, we can use hair conditioners. One of the conditioning agents used to prevent this highly charged hair surface are the cationic polymers. These act by neutralizing the negative charges of hair and consequently decrease the static electricity and improve softness and shine. The problem is that most of the cationic conditioning agents found in our cosmetics are produced from non-renewable resources and are poorly biodegradable. In addition, they are reported to be toxic to aquatic organisms. This means that when we use these products on a daily basis, we are constantly releasing these harmful components to the environment. Based on this, it is important to find new alternatives to these cationic conditioners. This is also motivated by the growing awareness of the consumers and their preferences towards natural-based products. Studies have shown that more than 80% of the consumers have a positive overall perception of bio-based products and of their environmental benefits. Also, 2/3 of them prefer to use these products over the non-bio-based products. However, only 26% of the consumers states that it is easy for them to find bio-based cosmetics or easily identify them on the market. So it is clear that people are interested in bio-based products, but more solutions must be available on the market or at least well identified so that consumers can easily find them and become aware of their benefits regarding the impacts on health and on the environment. With this in mind, our goal is to develop new sustainable cationic lignin derivatives with conditioning properties to be implemented in hair care formulations. And why lignin? Lignin is a natural aromatic polymer found in lignocellulosic materials such as wood or agricultural wastes. It is one of its main components and accounts for near up to 20 up to 30% of the biomass weight. So this makes lignin a highly abundant natural polymer. It also presents some interesting properties that makes it an appealing ingredient for cosmetic products. These properties are its biocompatibility and its antimicrobial activity, and also its UV protection, which could be useful for additional hair protection against sun exposure. So, to accomplish this, we started by extracting lignin from wood using green technologies, namely dipeptidic solvent systems, and we could successfully extract all the lignin present in acacia wood with the purity of more than 90%. Then we started working on lignin cationization techniques, where we selected two different routes: a direct cationization by grafting quaternary ammonium compounds, and also the Mannich reaction with amines that can give us lignin derivatives which can be charged or neutral based on the pH of the solution. With this second approach, we could successfully obtain modified lignins, but these were only cationic at very low pH values, lower than those of the hair conditioner formulations, so we decided to explore in more detail the first approach, where we used GTAC as our cationizing agent. This is a very straightforward method, where we dissolve lignin in an aqueous sodium hydroxide solution, then add the GTAC and let it react for 3 hours. This is our experimental setup. So, as fixed factors, we have the reagents, acacia lignin and GTAC, and also the reaction time, that is 3 hours. Then our variables or the temperature, where we selected 3 different temperatures and also 3 different molar ratios. Then we performed the design of experiments, and the responses that we evaluated were the degree of substitution and also the zeta potential of the derivatives. Here we can see the results that are graphically represented, and we can see that we could successfully modify our acacia lignin, obtaining degrees of substitution between 0.31 and 0.56. And as for the zeta potential, our unmodified lignin presented a negative zeta potential, and after the modifications, this value was increased, becoming positive for all the reaction conditions where a temperature of 50 or 70 degrees were used. To have a better perception of the effect of each variable and to find the optimal conditions, a design of experiments with a response surface methodology was implemented. Here we have this table with the experimental results obtained for each response and the predicted results from the model, and we can see that the predicted and actual results are very similar. What was expected, since the models for both the responses had high R-square values of more than 0.98. We can observe that the temperature has a significant effect in both the degree of substitution and zeta potential, in contrast to what happens for the molar ratio. The models described by the equations were then used to generate the response surfaces, and here we can visualize the difference between the effects of each variable. Along the molar ratio axis, there is no great variation of the degree of substitution or the zeta potential. On the other hand, increasing the temperature results in high increases in the degree of substitution and in the zeta potential. Although the model predicted that the best conditions were at higher limits of both variables, due to the negligible effect of the GTAC to lignin ratio at these conditions, we selected the lowest GTAC ratio at the highest temperature as the best condition, since this is more economical and environmentally favorable. Based on our findings, we identified optimal reaction conditions that balance efficacy with the environmental and economic considerations. Additionally, we explored strategies to enhance the reaction efficiency. First, we performed the reaction for a larger time, for 24 hours instead of 3, and we observed that the zeta potential was not affected, but the degree of substitution was increased. More interesting is that we also find that if instead of performing such time-consuming reactions, we increase the quantity of sodium hydroxide added to the reaction, we could obtain similar results. This is a more economical way to boost the reaction. However, more tests are needed to understand what the optimal amount of sodium hydroxide would be to add to the reaction medium. Then, the modified lignins were characterized by infrared spectroscopy, and we can clearly see the presence of a new peak in the cationically modified lignin that isn't present in the original lignin. This peak, which is highlighted with the dashed line, is characteristic of methyl groups attached to the quaternary ammonium atoms. This shows that the GTAC is present in lignin derivatives, proving the effectiveness of the cationization reaction. Based on our findings, we can conclude that the cationization of lignin with GTAC is a viable approach for the production of cationic polymers. We also observed that temperature is a crucial parameter that affects the degree of substitution and zeta potential of modified lignins, and that adjusting the quantity of the sodium hydroxide is a cost-effective method to improve reaction efficiency. With this, we conclude that the strategy presented here is a promising route for the production of natural cosmetics, namely hair conditioners, which we expect to contribute to decrease the environmental impact of cosmetic products and also to fulfill the consumer's expectations. But because this is an ongoing work, a lot still needs to be done. The next steps will include a more in-depth characterization of these lignin derivatives and, of course, some toxicity assessment in terms of both ecological and skin toxicity. And then some studies on how these derivatives interact with human hair, so we can select the best candidates for the development of the actual formulations of hair conditioners. I would like to finish my presentation by thanking my supervisors and all the team that worked with me in this project. Thanks FTT for the financial support, and thank you all for your attention.
Thank you for a nice presentation. So we have time for questions. Are there any? Dominika?
Yes, hello. I have two small questions. Can the origin of lignin affect its properties, and what toxicology test do you want to do?
Hey, thank you for your question. We know that different species where we extract lignin from will impact on its structure. For example, we know that lignin from hardwoods differ from lignin from softwoods, both in terms of its structure and also its processability. But we don't have information how it will affect our formulations. We expect that in terms of conditioning properties, both origins could be useful, although probably we will need to adjust the parameters and the modification of both types of lignins because of their different reactivity, but we don't have any actual information about this. We are only using lignin from hardwood, that is acacia wood. Regarding your second question about the toxicity assessment, we are now conducting some experiments on the ecotoxicological effects of these cationic polymers. We select two different modified lignins, one of a high degree of substitution, that is highly cationic, and another one with a lower degree of substitution. And we are testing them on the inhibition of fish growth and some algae and other aquatic organisms, but we don't have the results yet.
Okay, thank you.
Thank you.
Okay, so maybe one quick question, if someone ask. So maybe I'll ask a quick question. So is this method like expensive? Because at the end, I presume that you would like to kind of commercialize it. Yes. So would it be more like is the method will be like more expensive to which are now you know, the products that are now made, or it will be like maybe less expensive? You know something about it?
We don't have this information yet. We didn't run an economical analysis, but we know that some biopolymers like cellulose are now used to produce hair conditioners, and namely cationic cellulose that are modified with this same reaction. So if we have a polymer that is derived from the same biomass material and is modified with the same process, we expect that the cost will be the same as the currently used bio-based polymers. Probably comparing to these petroleum-based polymers, it's possible that could be a little more expensive, but because they are not so available as these highly commercial polymers. But these would be interesting to perform an economical analysis at the end of the optimization, so we can compare not only the environmental benefits but also the economical benefits of this process.
Okay, thank you very much. Thank you also for the presentation, for the questions. So let's move to the next speaker. So the next speaker is Aleksandra Florczyk from the Jagiellonian University. So the virtual floor is yours. So please go ahead and play the video.
Ladies and gentlemen, I'm enjoyed to present my research on the topic of exploring the potential of vancomycin-loaded hydrogel-based system in antibiotic therapy. This research was carried out of the Faculty of Chemistry in cooperation with the Faculty of Biochemistry, Biophysics and Biotechnology. Surgical site infections pose a significant challenge for the medical service. Systemic antibiotics may be insufficient in preventing bacterial biofilm development. With the local administration of antibiotics, it is easier to minimize possible systemic complications, achieve drugs higher concentration at the injured site, as well as provide a more sustained release. Therefore, the main objective of the proposed studies was the fabrication and characterization of innovative hydrogel-based composites for the local vancomycin therapy. Vancomycin is a broad-spectrum antibiotic generally prescribed to combat severe infections caused by gram-positive bacteria. Moreover, vancomycin is recommended for the treatment of brain tumor in post-operative neurosurgical patients. The aim of the research was achieved by using the following tasks. Firstly, synthesis and characterization of polymeric carriers loaded vancomycin. Secondly, synthesize and characterization multifunctional hydrogel-based biopolymeric matrix with those nanoparticles. Focusing on hitosan nanoparticles were fabricated by the ionotropic gelation method using 3-polyphosphate sodium, in short TPP. The compound was loaded into polymeric nanoparticles, which were then attached to a chemical cross-linked biopolymer-based hydrogel matrix consisting of collagen, chitosan, and modified hyaluronic acid. It is expected that such designed system will enable direct delivery on the active substances to the disease environment, thus reducing the systemic toxicity and providing control release. The obtained materials were characterized for their physicochemical and biological properties. Analyze nanoparticles tracking analysis NTA. The sample with the highest content of vancomycin was characterized in terms of size distribution by means of dynamics in light scattering, nanoparticle tracking analysis, and scanning electron microscope techniques. First two figures at the top of the slide shows the size distribution profiles determined from NTA presenting the relationship between formulation size and particles concentration in the dispersion. The experimentally obtained concentration for sample C3 is approximately 8.61 times 10 to the power of 10 particles per milliliter. Finally, to visualize the developed particles, they were analyzed being embedded with the hydrogel by means of scanning electron microscope. Based on the obtained SIM images and taking into account the size of 190 objects, a histogram was made, as you see at the very bottom of the slide. As can be seen in chart, the highest number of particles with diameters of about 170 nanometer is revealed. Calculate the encapsulation efficiency of vancomycin loaded in the chitosan nanoparticles, the ultraviolet visible spectra of the initial sample, and this after centrifugation, concentrate, and filtrate were recorded. The excess of free vancomycin has been removed by Vivaspin concentrators. The dependency of the absorbance of the wavelength in figure shows the maximum absorbance at 280 nanometer for each of the fractions. Thus, the estimated encapsulation efficiency of nanoparticles with the highest content of vancomycin was 60%. Moving on to the most important part of the research, which is the release profile. Chitosan nanoparticles loaded with labeled vancomycin and hydrogel systems with embedded chitosan nanoparticles with drug and hydrogel with free vancomycin named control. Each sample was in the same concentration. The antibiotics release under model physiological conditions was evaluated. The percentages of cumulative drug release from developed formulations is present in the top of the slide. The vancomycin release from nanoparticles ended after 7 days, as the same as sample name control, when the cumulative percentages of drug release achieve about 100%, whereas the hydrogel where can be studied for more days. After 7 days, only about 60% of the drug loaded at the beginning was released. These results clearly demonstrate that collagen chitosan functional hyaluronic acid matrix provide additional protection from uncontrolled drug diffusion. Swellability is one of the essential properties of hydrogel materials that strongly affect their use in the drug delivery. Therefore, the development composites were evaluated for the swelling ability under physiological conditions. As a control is a hydrogel with embedded hydrogen particles without drugs. The highest swell ratio value 1,500 was observed for hydrogel with the lowest content of vancomycin, while the lowest swell ratio 1,200 was revealed from the control system. Developed hydrogel-based materials were tested for degradation performed under physiological conditions. The weight loss was monitored for approximately 30 days, and the results are displayed chart next to the drawing of the incubator. The observed tendency for all samples is similar. The kinetic of the degradation process was slow and gradual. To verify the biocompatibility of developed composites, we have performed the preliminary biological studies in vitro utilizing MG63 cells as a model. The result of a viability test carried out with Alamar Blue assay on the first and third culture day are shown. For all developed composites as well as the control sample, the same tendency with the prolongation of the experimental time was found. Since cell adhesion is one of the important parameters in determining the biocompatibility of materials, we have also evaluated the morphology and ability of MG63 cells to attach to the surface of developed system. Analyzing images of the higher magnification, the 3D polymer network along with embedded rounded in shape particles are also well visible, and morphology of cells that were characterized by well-defined and elongated shapes. The antibacterial effects of the obtained materials was proven through a visible zone of inhibition. A spherical structure of nanometric sizes were obtained and characterized. The encapsulation efficiency of vancomycin in hitosan nanoparticles was approximately 60%. The release of vancomycin from hydrogel materials is significantly extended compared to nanoparticles in control. The antibacterial activity of the hydrogel was confirmed. The in vitro cell culture study showed that the surface of all prepared materials are biocompatible. It is anticipated that this designed system will facilitate the target delivery of the active substances to the affected area, thereby minimizing system toxicity and ensuring controlled release. There is very hope that these innovative materials may be approved for use in the human body. The future of biomaterials research focused on nanoparticles development holds great promise. Thank you for your attention.
Thank you for a presentation. So we have a time for questions. So Dominika raised her hand. So that.
Yes, I have question. I'm sorry. What difficulties may occur in the synthesis of hitosan-based nanoparticle?
Okay, could you repeat?
What difficulties may occur in the synthesis of hitosan-based nanoparticle?
Difficulties, for example, sometimes it's hard to prepare nanoparticles based on hitosan with the same spherical structure, and yes, that's all.
Okay, thank you.
Okay, Magdalena.
You mentioned dynamic scattering measurements for nanoparticles in your presentation. Hence the question, what is the size distribution for the tested systems?
Okay, spherical structure of nanometric sizes were obtained and characterized. Hydro diameter and dispersity index values about 200 nanometer and low dispersity index. Overall, by comparing these three techniques used for measure the sizes of obtained structure, it was observed that the DLS and NTA results are in good agreement. However, when using scanning microscope electron, the object's diameters were lower. Because SIM informs about sizes and shape of this object without the solving shell removed previous by leftization.
Thank you.
Okay, so we kind of don't have time for more questions, although there is one in the chat. So if you, Alexandra, could write an answer in chat, and we'll go to the next next presentation given by Paulina Gwardys from the Warsaw University. So we can play the video if you're ready. Are we ready? Yes.
Welcome to my presentation. I am Paulina Gwardys and I am second year PhD student at the Doctoral School University of Warsaw. Today I want to tell you about microgel anchored on conductive surface as controlled release system. I conduct my research under the supervision of Professor Marcin Karbasz and Dr. Kamil Marcisz. Why are controlled drug delivery systems needed? Conventional drug delivery systems like pills and ointments have a lot of limitations, including limited absorption at the disease site, of course, difficulty monitoring, fluctuations drug levels in plasma, burden of the liver, and premature shedding from the body. Therefore, the goal of scientists is to develop drug carriers that will be targeted to a specific disease site, where the drug will be released at this targeted disease site under the influence of internal factors like, for example, pathological pH in cell, or external factors like, for example, electrical impulse, which additionally will be non-toxic. For example, hydrogels are promising drug carriers. These are cross-linked hydrophilic polymer networks filled with an aqueous solvent. Hydrogels from the SMART group have the ability to significantly change their volume in response to various external factors, depending on the polymers that build them. The most widely examined are thermosensitive and pH-sensitive hydrogels, and they are often biocompatible and sensitive to more than one environmental change. This allows them to precisely release drugs in pathologic areas, minimizing toxicity to healthy cells. Currently, attention is being paid to electroactive hydrogels, so those that have a redox active molecule in their structure. And in the last project, I obtained this an electroactive microgel. It was synthesized by distillation polymerization, and microgels have spherical structures of size corresponding to colloidal particles, and they are characterized by low viscosity and very high surface area. Microgels are particularly interesting due to their ability to undergo rapid and reversible volume phase transition. And here we can see monomers that were used to synthesis, and they were precisely selected due to the presence of this carboxyl groups from acrylic acid in the microgel structure. It is possible to generate a negative charge and appropriate pH. And cross-linking agent, it was BAC, and it's not only to cross-link two linear polymers, but also thanks to this sulfur bridges, it ensures strong sulfur-gold interactions and allows the microgel to be deposited on the gold electrode surface. And here we can see EIFMA modified with furazine. Furazine is redox active molecule. And all of these components were dissolved with in acetonitril, and initiator of polymerization was added. It was ABN, and it was breaking down but into free radicals, and this reaction could be started. So the structure of obtained microgels looks like this, and here we can see linear polymers with carboxyl and furosine groups, and here is this cross-linking agent with these sulfur bridges. And after this reaction, I dialyzed microgel in a lot of water to get rid of this, to remove this unreacted compounds and organic solvent. Then I investigate properties of this received microgel material. First, I measured size depending on pH with the dynamic light scattering instrument, and we can see here in pH 2 the size was about 200 nanometers, and in pH 10 it was about 800 nanometers, and this transition point was in pH 6. This shape of curve is characteristic for hydrogels based on polyacrylic acid, and actually in lower pH, in this acidic pH, carboxyl groups are protonated and hydrogel is in shrunken state, and in alkaline pH, carboxyl groups are deprotonated, there is negative charge, and hydrogel is in swollen state. And to confirm this size of microgel, I also made the transmission electron microscopy photo. And we can see in here that this radius was about 200 nanometers. Next, the presence of individual elements was examined by energy dispersive spectroscopy, and was confirmed that in addition to carbon, nitrogen, and oxygen that are characteristic for organic compounds, there was also iron and sulfur atoms in significant amounts. And it confirms that all my components were incorporated into this microgel structure. In the next step, the electroresponsive properties of microgel were studied, and here we can see cyclic voltammograms in supporting electrolyte with pH 3 and 10, and this measurement were carried with 3 electrode system, where the working electrode was glassy carbon electrode. And we can see well-formed characteristic for furosine peaks from oxidation and reduction. And here in pH 10, this hydrogel is in swollen state, so these peaks were shifted to lower potentials, but still they are good, very good formed. Then, in the next step, I wanted to obtain a microgel monolayer on gold electrode surface. So this process of hemisorption was monitored with quartz crystal microbalance with energy dissipation, and to do this experiment, I put 1 milliliter of water with pH 3 to this QCTMD vessel, and then I add 150 microliters to this vessel, and we can see this decrease in frequency that indicates increase in mass on the electrode surface. So that means that this monolayer was formed. And of course, to confirm this monolayer is formed on this gold electrode, I also made a scanning electron microscopy photo, and here you can see also this well-packed microgel monolayer on gold electrode surface. Then I also investigate this monolayer on this gold electrode properties. So I made this cyclic voltammograms with supporting electrolyte pH 3 and 10, of course with this 3 electrode system, but here working electrode was this gold electrode. And here also we can see well-formed peaks from fluorescein, but for pH 3 they are shifted to more positive potentials. And then I wanted to incorporate my model substance in microjoule structure, and I monitored this process with this quartz crystal microbalance. This model substance was crystal violet. It is a positively charged dimolecule, and this process was monitored with this QCMD. So I put here 2 milliliters of water, and then I add 50 microliters every 15 minutes of this dye solution, and we can see the greatest changes for this first addition, and after 1 hour actually there is a plateau. So we can see that this dye molecule was incorporated into this microjoule structure by electrostatic interactions with carboxyl groups. Then I rinsed this monolayer with a lot of water to remove this unbound dye molecules, and then I could make this release profile. So we can see here this idea was to that by oxidizing this fluorescein and generate a positive charge, there could be competitive electrostatic interactions with these carboxyl groups, so the molecule could be released to solution above the monolayer. And here you can see that I put 3 milliliters of supporting electrolyte to QCMD vessel, and then I mixed this solution. Then I collect 1 milliliter to quartz kiewit, and I measured UVV spectra, and I return this 1 milliliter to QCMD vessel. Then I also mix it, and I do this 3 times in time, these measurements, and then I record cyclic voltammogram, and I applied potential of oxidation, this fluorescein for 1 minute, and these red arrows indicate like this is activation and termination of applied potential. Then I also measured 3 times in time UVV spectra, and so on. And we can see this stepped releasing induced by electrical impulse. Next, this dark blue triangles. It is continuously applied potential for 6-10 minutes, and we can see that after 5 minutes there is actually a plateau. And also with these steps pulses, we can see that after 5 1-minute long pulses in here, there is a plateau. So we can say that after 5 minutes of applying potential, all the molecules that could be released, they are released. And here also is measured this releasing of the molecule, but without applied potential. We can see a little leakage this dye molecule from microjoule structure. I also made this calibration curve for this dye molecule, low concentrations, and here we can see the result. And after this, I could calculate this plot with absorption of time, absorbance in time to concentration in time, and here is this result. And actually, what's the point of this? Why I am even making effort to conduct this research? Yeah, because electrochemically controlled release systems of active substance represent a significant advance, expanding the use of hydrogen materials in both intrabody implants and transdermal patches. This innovative technology enables precise targeting of the drug to specific disease sites and control concentration of the drug. The benefit of the solution is the ability to conduct therapy without additional burden of the liver and the dark carrier is inserted and removed with the electrode. Additionally, carefully selected potentials guarantee the safety of the process, minimizing toxicity harmful effects on health. Yeah, thank you for your attention.
Okay, thank you for the presentation. So we have like time for quick 1 or 2 questions. Is there any? Okay, so there is one in the chat. Can you answer the question, please, Paulina?
Yes, good afternoon. Yes, actually, we didn't check these properties in protic and aprotic solvents. We just wanted to make this releasing system. So we tried to make it more like a physical in body conditions. So more like pH 7 and water. Yeah.
Okay, thank you for the answer. So is there any other? I see not. So thank you very much for a presentation and for an answer. So let's move to the next speaker, Katarzyna Medyńska from the Warsaw University of Life Sciences. So if we're ready, we can play the video.
Good morning, ladies and gentlemen. Thank you for your coming. My name is Katarzyna Medyńska and I'm a doctoral student at Warsaw University of Life Sciences. Today, I would like to present the results of my research, which I conducted together with Professor Katarzyna Wiktorska, also from my university, with Professor Maciej Mazur from the Department of Chemistry, University of Warsaw, and with Anna Pogorzelska from the National Drug Institute. The title of my presentation is The Impact of Plant Compounds with Anti-Cancer Properties on Liposomal Doxorubicin in Triple-Negative Breast Cancer Oncological Therapy. Cancer is a major public health problem worldwide due to its high incidence and also high mortality rates. The charts below show the total number of cases and deaths caused by cancer for women and men in 2020, it's over here, and the expected values for 2040. As you can see, unfortunately, in each case there is an upward trend, and it's assumed that over the years the values shown here will not change significantly. The type of cancer with one of the highest incidence rates was selected for the study. It's breast cancer, or more precisely its most aggressive form, that means TNBC, so triple-negative breast cancer. TNBC is characterized by the lack of expression of progesterone and estrogen receptors and overexpression of HER2 receptors, which makes it unfortunately difficult to choose the appropriate targeted treatment method, for example, hormone therapy. In this case, the only effective method is chemotherapy. It's significantly invasive and it's usually larger than other types of breast cancer, leading to recurrences and metastases. TNBC tumors show inherent resistance to therapy as well as acquired resistance after treatment cycles. In our studies, doxorubicin was used as the targeted drug, and the plant-derived compounds with anti-cancer properties were sulforaphan, chlorophyll, and chlorophylline. Chlorophyll and chlorophylline are compounds from the same chemical group, but they have different physicochemical properties. So the reason for using these two compounds was to check whether they had similar effects despite of having different properties. The combinations created in this way were encapsulated in liposomal formulations and then introduced into cancer cells into the MDA-MB231 cell line. On this basis, a number of studies were performed, starting from the characterization of liposomes and the analysis of the DOX release profile, and ending with the analysis of the survival of cancer cells. So let's go now to the results. The characterization of liposomes includes the analysis of their stability, polydispersity, and most importantly, their size. It's believed that for medical use, liposomes should have a size of 50 to 100 nanometers, because when liposomes are smaller or larger, they may be immediately removed from the bloodstream. As you can see, each combination yielded a size within this range, suggesting their use in a treatment. Another study was the analysis of encapsulation efficiency using two methods. The first one was UV spectrophotometry, and the second one fluorescence spectroscopy. As you can see, the obtained efficiency values range from 60 to 92%, which is a satisfactory result. The values obtained for fluorescence spectroscopy are higher than for UVVs because it's more sensitive method. Then an analysis of DOX release profile was performed at the two pH levels. The first one was 6,5, which was supposed to reflect the reaction of the extracellular matrix of cancer cells, and the second one, 7,4, representing the reaction of blood. That means the situation when the tested substance is introduced into the bloodstream. As can be seen at pH 7,4, very small amounts of DOX are released, especially in the case of combinations of drug with plant compounds, which may suggest that such combinations can protect healthy cells against the effects of chemotherapy. The opposite situation can be observed at pH 6,5, where the amount of DOX release reaches up to 80%, which confirms then the increased release of DOX at the target site. The size of the spheroids after introducing the obtained compounds into them was also analyzed, along with decreasing DOX concentration. As you can see, liposomal formulations with DOX and plant compounds are the most effective because there is a significant impairment of homogeneity of cellular aggregates and the formation of dead cells. The opposite is for liposomes with the chemotherapeutic agent alone, where even after the introduction of liposomes with the highest concentration of DOX, the cell aggregates were more compact and homogeneous. However, most importantly, with increasing DOX concentration, spheroids disappear and an increasing number of dead cancer cells appear. The last study was the analysis of cancer cell survival using the PrestoBlue test. It's a test using for 3D culture. This experiment was also intended to show the impact of compounds B and C on cell viability and the potency of DOX. As can be seen, lower survival values are for the combination of DOX with compound B, up to 20%, which suggests its greater effectiveness than compound C, which is due to the fact that it's located in the wall of liposomes, thereby increasing their permeability to encapsulated drugs. To sum up, it was possible to obtain liposomes containing the intended combinations of compounds, which were of sizes enabling their use in medical applications. Additionally, satisfactory DOX encapsulation values were obtained. Also, the results of the release profile in two types of pH confirm the effectiveness of the obtained formulations, and based on the analysis of spheroid sizes and the survival test, the effectiveness of the created combinations in the treatment of TNBC was proven. Currently, further studies are being performed to improve the results obtained and increase the effectiveness of drugs.
Okay, thank you for a presentation. Very quick, I must say. So unfortunately, Katarzyna has some problem with mics. So if there are any questions, then you can. Okay, so let's go with Łukasz. So.
Hi, thank you, Katarzyna, for the very nice presentation. So I have a question regarding the way of admission of such drug. How would you plan to administer it into the patient? Would it be like intravenously, or yeah? That's my question.
Okay, and we can, because we have some time, we can kind of wait for an answer. And also I see that there is a question also in chat. It's kind of unfortunate that the mic broke, like some technical difficulties, but. Okay, so there's a third question on chat. Okay, so maybe I think so. We'll not like I don't know. Should we maybe let Katarzyna answer a question and for us like not to stay and I don't know, like looking at the chat, maybe we can go for the next presentation, maybe. Because I presume it will take some time to answer each question by typing. So I propose to move to the last speaker of these sections. Maybe. So let's move to the Robert Frankowski from the Poznań University of Technology, which is also the video presentation. So if we are ready, we can play the video, and the question for the and the answer for the questions will be in chat for the previous presentation. Okay.
Good morning. My name is Robert Frankowski, and today I will present my research on exposure to potentially toxic metals through ingestion of Arabica and Robusta coffee infusions prepared in aluminum and steel moka pots. So to briefly summarize coffee, because we all know about it. Coffee is a hot beverage brewed from the roasted coffea plant beans. It's darkly colored, bitter, and slightly acidic. Coffee has a stimulating effect on humans, primarily due to its caffeine content. It is the highest sales in the world market for the hot drinks. As you can see here on the figure 1, caffeine chemical structure, as well on the figure 2 and 3, the coffee plantation and the coffee fruits, raw coffee fruits. On the topic of classification of coffee, you can see scientific classification on the left side, and all you have to know that there are over 120 species of coffee. The two most popular are Arabica, which accounts for around 60 to 80% of world's coffee production, and Robusta, which accounts for about 20 to 40%. The other classifications can be divided into geographical, so from coffee from South America, Africa, Asia, or botanical, which differs the coffee Arabica. We make the Arabica coffee from it, and the coffee Canephora, we make the Robusta coffee from it. Now, this distinction, Arabica and Robusta, they're quite different. The Arabica requires heights between 800 and 2000 meters over the sea level, temperatures between 16 and 24 Celsius, and the resistance is quite low, as well as the caffeine content between 1.1 and 1.7%. Robusta, on the other hand, require height above 800 meters, temperatures slightly higher between 22 and 30 degrees Celsius, has a high resistance and higher caffeine content between 2 and 4.5%. On the map, there are presented countries that produced coffee. And the brown color represents the nations that over 100,000 60-kilogram bags are produced equally there. And as you can see, they're all centered right above the equator, and it's something called the bean belt. Bean belt represents the perfect conditions to growing the coffee plant. So it's around the equator of our planet. So some of the applications of the coffee, because it's rather known for the hot beverage, but we also use it as a food additive. We add it to cosmetics, some medicines, pharmaceuticals, even because of its health benefits. Health benefits of the coffee are the reduced risk of cardiovascular disorders, decreased possibilities of diabetes, and the prevention of depression, sclerosis, or even the Parkinson's disease. But for all the benefits, it also has some health risks because of its high caffeine content. So some of the risks are increased risk of insomnia, could be headaches, anxiety, and for the pregnant women, it could be low birth weight or preterm delivery. After this brief introduction, now head to the methodology part of this presentation. First of all, let's talk about aim of the study. The purpose of the study was to compare the content of trace elements such as nickel, chromium, and aluminum in the beans and infusions depending on species of the coffee plant. So if it was Arabica or Robusta, their country of origin, whether the coffee was roasted or green, and brewing method, so brewing in the steel or aluminum moka pot. Here's the table of our all samples. From the left, we can see abbreviations. So what we use to describe this particular coffee. Then there's country of origin and region. Then there is the washing part, either it was unwashed or fully washed. And then there are additional information get to by the producer of this coffee. So how to read the abbreviation? On the left example, we can see that first letter is the coffee type, so Arabica or Robusta. Then there is the country of origin, so it could be Brazil, Colombia, Uganda, Vietnam, plus region, so Modiana, Bugishu, Drugar, Konilon. Then the following letters are the additional information. If it was steamed, if it possessed 5% black beans, for example, and the last letter is the roasting procedure, so it could be green or roasted. On the right example, we can see that A represents Arabica, BM Brazil Modiana, and then G represent that this coffee was green. All of the abbreviation can be seen on the small table on the bottom right side. The next step was the sample preparation. It starts with grounding coffee, either it was green or roasted, then brewing it in mocha steel pots or mocha aluminum pots, or 5 grams of coffee in 100 milliliters of water for 10 minutes in Erlenmeyer flask. The next step was the filtration of the brew and microwave assisted digestion in a vessel with peroxide and nitric acid. This table presents all the parameters for atomic adsorption spectrometry for all the elements. So like the wavelength for aluminum, chromium, nickel, the spectral range modifier, sample volume, pyrolysis and atomization. And that's most important is level of detection between 400 and 500 micrograms per liter, and the precision between 8 and 15%, and recoveries between 91 and 110%. For the risk assessment, we make calculations for the hazard quotient, dividing average daily dose by the reference dose. Those average daily dose is the greatest concentrations of some element that we obtain, multiplied by ingestion rate, exposure duration, and divided by the body weight and average time. The reference dose was calculated by taking the no observable adverse effect level divided by the uncertainty factor and modifying factors. These factors are taken from the literature for these calculations. And now for the first part of our results, the metals concentrations. Let's start the content in coffee beans of our elements. Starting with aluminum, we can see that their mean concentrations is lower in the roasted coffee than in the green coffee beans, reaching up to 70 micrograms per gram. For chromium, there is hard to get some trend going on in this graph, but we can see that its concentrations in the beans is much lower, ranging between 0.6 and 1.6 micrograms per gram. But for nickel, we can clearly see the difference between roasted and green coffee beans. For roasted, there is concentration of nickel below the 1.5 micrograms per gram, but for green coffee beans, this concentration reach up to 4 micrograms per gram. It could be due to the volatilization of the nickel species during the roasting process in the high temperatures. Now let's move to infusions of coffee. Starting with the aluminum content in them, you can see that concentration of aluminum in the coffee brewed in the still mocha pot, it's up to 250 micrograms per liter. But those brewed in aluminum mocha pot, it's much greater, reaching over 1000 micrograms per liter. Raising about 4 to 5 times for each coffee, with the distinction of the Robusta from the Brazil, which concentrations was 46 times greater, comparing the two mocha pots still, and aluminum. It could be due to leaching of the aluminum from the mocha pot to the infusions due to the acidic environment of the coffee. Now moving to chromium, you can see that coffee brewed in steel mocha pot has higher concentrations of this element, reaching up to 10 micrograms per liter, comparing it to the coffee brewed in aluminum mocha pot, which has around 3, but does not change dramatically when compared to green and roasted coffee. Fairly similar results were obtained for nickel, which has some leaching of the nickel element from the steel mocha pot, reaching up to 70 micrograms per liter, compared to the aluminum mocha pot, which reach about 40 micrograms per liter. Now, because the pH of the brew has effect on the leaching of the elements from the mocha pots, we measured this parameter for all the coffees. And as you can see, material of the mocha pots does not change the pH value dramatically for each coffee, but average pH of the Arabica and Robusta green coffees are slightly different. Robusta green is slightly more acidic than the Arabica green, and other way around for the roasted coffee, when Arabica is slightly more acidic. On the far right, you can see average pH for the green and roasted infusions, and clearly it can be seen that roasted coffee is slightly more acidic, pH ranging at around 4.8 comparing to 5.7 for the green coffee. Now for the last part, so the risk assessment of coffee consumption. So you may ask, what is the risk of coffee consumption made in mocha pots? For the aluminum, average daily dose calculated by us is 5.36 times 10 to the minus 3 micrograms per kilogram per day. The hazard quotient value obtained is below 0.2. This is the still a safe level, and even a coffee intake 5 times higher than those one considered in this study will not result in risk to the average person. For the chromium and nickel, those average daily doses are much lower, so this indicates negligible effects of these elements on human body. Now for the last part, conclusions. First of all, the origin of coffee beans plays a role in the aluminum, chromium, and nickel content in them. Steel mocha pots increase concentrations of chromium and nickel in brews. On the other hand, aluminum pots increase aluminum content in coffee significantly. Coffee made from roasted beans is more acidic than those made from the green beans. Material of mocha pots does not change pH of the coffee significantly, despite aluminum hazard quotient is much higher than for chromium and nickel. It is still safe for human consumption and health. Chromium and nickel are at negligible levels in coffee brews, therefore does not pose a threat for humans. Thank you for listening.
Thank you very much for interesting presentation. So we have time for some question. Are there any? Dominika?
Yes, I have a question. Where did you get the coffee for the test? Are these commercial available products that we can find on stores shelves?
Yes, exactly. We get coffee from one producer that's it was, I'm searching, so Strauss Coffee. Oh, Strauss Coffee. We get all of the samples from them, and it was green and roasted coffee, and for other publication we even get in the different stages of roasting.
Okay.
But it was one distributor.
Okay, thank you.
Are there any other questions? I see that there is one in chat, so if you can answer that, Robert.
for coffee lovers, right? My comment that is huge surprise that China is such a large producer of coffee. And then there is Italian coffee pots main. Aluminum coffee pots are safe because we get the results of the hazard quotient of below 0.2. So basically, you have to get 5 times this much coffee that we assumed based on the publications to reach the level of starting to get somehow dangerous for humans. But it's not, if you drink 3 cups of coffee, you are perfectly safe.
Okay, thank you very much, because I heard from some people that it's very risky to brew coffee in aluminum pots. So when I saw your presentation, it seems that the type of coffee is more important rather than the pot. Yes?
Yes, yes.
Thank you very much.
Or like chromium, right? But these are still negligible levels. So we can...
Thank you. So we can drink coffee all the day.
All day. Maybe
Yes.
not.
Thank you very much.
A day for a whole life. Then it might be a problem for aluminum content.
Thank you. Thank you very much.
Thank you very much.
Okay, so is there no other questions? So I think we can close the this block of the oral session. So we'll have a big break till the full hour. So the 3 p.m. Polish time, 2 p.m. London time. After that, we'll have a last oral session, and after that, there will be a poster session, and that's it. So let's hit for a break. Don't go far. Yes, and see you soon. So break is over. So let's head to the last oral session of the conference, and after that we'll go to the again break, and after the break last poster session. So let's go ahead and start a presentation by Julia Płatkiewicz from Poznań University of Technology. So if you're ready, we can hit a play on the video.
Good morning. My name is Julia Płatkiewicz, and I'm a PhD student at Poznań University of Technology, the Faculty of Chemical Technology. The topic of my presentation today is the biodegradation of antifungal derivatives of imidazole and triazole by activated sludge. In today's presentation, I'm going to cover 4 main points: theoretical introduction to the topic of azole's degradation, the methodology of my research, as well as results. Then I will shortly summarize the main conclusions. Due to the increasing environmental pollution and the impact of harmful substances on organisms, research into the determination and removal of pollutants are becoming more important. The particular attention is given to the antifungal substances such as azoles. They are a class of 5-membered heterocyclic compounds which are composed of at least 1 nitrogen atom in their rings. Azoles exhibit diversified biological activity, however, they are mainly known as antifungal agents. Their action is based on the inhibition of ergosterol synthesis, which is necessary for the creation of the fungal cell membrane. Azole substances are widely used as active ingredients in human and veterinary medicine, agricultural fungicides, as well as personal care products such as dermal creams, toothpaste, hair shampoos, and soaps. Due to the chemical structure of azoles, imidazole and triazole classes of compounds can be distinguished. The former compounds include climbazole, clotrimazole, miconazole, econazole, and ketoconazole. They are an important group of azole antifungals characterized by relatively high lipophilicity and mostly used as human and veterinary medicines. Triazole compounds, such as tebuconazole, epoxiconazole, flutriafol, are mostly used as common agricultural biocides, while fluconazole is used for treatment of fungal infections in humans. Because of the ecotoxicological threat of azoles antifungals, such as adverse effect on endocrine system in animals, growth retardation in plants, and increase of drug resistance fungi, they are considered as emerging environmental contaminants. After use, these substances are flushed into environment and wastewater treatment plants. The presence of azoles was detected, for instance, in domestic sewage, hospital wastewater, groundwater, surface water, sludge, and biosolid amended soils. On the slide, you can see the results of my previous studies when I determined the concentrations of azoles detected in rivers, lakes, and field drainage channels near Poznań. As you can see, high concentration of tebuconazole was detected in Warta River. The samples collected from field drainage channels contain definitely the highest concentrations of tebuconazole, reaching 1,500 nanograms per liter. Another azole antifungal detected was fluconazole, reaching the concentration of 300 nanograms per liter. In order to confirm the pathways of entering of azoles antifungals into the environment, the determination of these compounds in the wastewater treatment plant's effluents was conducted. The samples were collected from 6 different wastewater treatment plants around Poznań. Monitoring of treated wastewater was carried out 4 times at 3 months intervals. The graphs illustrate that there were no significant differences between these months. The compound detected in the highest amount at each treatment plant was fluconazole, reaching average concentrations of 400 to 500 nanograms per liter and even 700 nanograms per liter in January in Pyeongchang. The obtained results confirmed that due to its properties, fluconazole is not completely eliminated by wastewater treatment plants and enters the environment. Another detected antifungals were climbazole, clotrimazole, as well as ketoconazole and tebuconazole. One of the main treatment technology in wastewater treatment plants is activated sludge process. It is based on the ability of microorganisms to convert contaminants into simpler, less toxic or non-toxic compounds. The bacterial biomass is dispersed in the form of flocks in an aerated tank that is continuously stirred and fed by sewage with organic matter. Then it is transferred to secondary clarifier, where the settling of microorganisms and organic matter takes place. Compared to advanced wastewater technologies such as phenton ozonation and photocatalysis, activated sludge treatment is economical and easy to be operated. However, most of the processes in the waste or water treatment plants are designed for the partial purification of wastewater, that is, reduction of major contaminants such as biological oxygen demand, pathogens, nitrogen and phosphorus compounds, and therefore they are not capable of treating substances at very low concentrations, normally in micro or nanograms per liter. Therefore, the understanding of the behavior and fate of azole fungicides in activated sludge process is the key to improve their removing efficiency. The scope of the research included the biodegradation tests of azole compounds with the use of activated sludge, the determination of azoles adsorbed on the activated sludge to exclude the removal by sorption, as well as the metabolic activity tests. Activated sludge for biodegradation tests was obtained from Central Wastewater Treatment Plant in Poznań and Wastewater Treatment Plant in Wojówiec. Their locations are presented on the map. The tests were carried out in bottles containing 10 milliliters of activated sludge and 90 milliliters of mineral media, spiked with an azole compound with the initial concentration of 1 milligram per liter and placed on the rotary shaker. The samples were taken from each bottle at certain time intervals, and the whole experiment lasts 35 days. After that, the medium with sludge was filtrated, and the sludge on the filter was analyzed to check if the adsorption took place. The analysis was conducted with the use of high-performance liquid chromatography coupled with tandem mass spectrometry. In order to assess the cell metabolic activity as well as the toxicity of tested compounds and degradation products, the MTT test was conducted. It is based on the enzymatic reduction of yellow soluble in water tetrazolium bromide into purple insoluble formazan salt by living cells. The MTT reagent was added to the sample and incubated for 2 hours. After that, the purple formazan precipitate was dissolved in propanthol, and its absorbance at the wavelength of 560 nanometers was measured. The intensity of the color was proportional to the number of living cells. Biodegradation tests showed that complete degradation was achieved for ketoconazole and clenbuterol with activated sludge from the central wastewater treatment plant. Slightly lower results were obtained for sludge from Borówiec wastewater treatment plant, but they still exceeded 90%. The biodegradation curves indicate that the degradation occurred during the initial 2 weeks of the experiment, which corresponds with the highest metabolic activity of the bacteria. Although the primary degradation of ketoconazole and clenbuterol was complete, the analysis of total organic carbon showed that complete mineralization had not occurred, and some organic metabolites were still present, which may be even more toxic than the original compound. The compound with significantly the lowest degradation results was fluconazole, reaching 13% of removal using activated sludge from Borówiec wastewater treatment plant and 10% of removal for sludge from the central wastewater treatment plant. Analysis of the percentage of the compound adsorbed on the activated sludge indicates that 7% and 2% of the initial compound of fluconazole was not degraded by bacteria but adsorbed on activated sludge. Also, the metabolic activity values of the bacteria are very low, especially from the second week of the test, indicating that the compound has a negative effect on bacterial viability. Buconazole and flutriafol are commonly used fungicides from triazole class. On this slide, it can be seen that their biodegradation curves are very similar. In case of buconazole, the highest removal rate was observed during first 21 days. However, it didn't exceed 70% and then stopped. The biodegradation process of flutriafol is the most efficient in the first 2 weeks. Then the rate of biodegradation slows down, and after 35 days achieves 40% of removal with activated sludge from wastewater treatment plant in Borówiec and 55% with activated sludge from central wastewater treatment plant from Poznań. The slower degradation in the second part of the experiment is caused by the strong decrease of living bacteria cells in the sludge. Also, the difference between wastewater treatment plants in the final stage of the experiment may be caused by higher amount of living bacteria cells in the sludge from central wastewater treatment plant. The degradation curves of econazole and miconazole show some fluctuations. We can observe the fast removal of miconazole during first days of the process, followed by slight increase in concentration. This phenomenon is caused by adsorption of azole compounds on the activated sludge and then desorption back into solution. After 5 weeks of the experiment, the removal efficiency of azoles with activated sludge from central wastewater treatment plant was around 80%, while with the use of activated sludge from Borówiec around 40%. A significant part of the removal of econazole and miconazole was adsorption on activated sludge, as between 20 and 30% of the initial amount of compounds remained on activated sludge after biodegradation was finished. In case of clotrimazole and epoxiconazole, the difference in biodegradation efficiency between different activated sludges is clearly visible, with 90% for epoxyconazole and almost 80% for clotrimazole with activated sludge from central wastewater treatment plant, and almost 50% for both compounds with activated sludge from borubiec. Also, the amount of living cells in the final stage of degradation is slightly higher for central wastewater treatment plant. These differences may be caused by various bacteria strains present in sludge and their immunity against metabolites, which may be toxic. It is important to notice that over 35% of initial quantity of clotrimazole is adsorbed on the activated sludge, and in comparison with the removal efficiency, we can see that only 10% of clotrimazole is removed by bacteria from activated sludge from Borubiec wastewater treatment plant. The conducted studies proved that methods used at the wastewater treatment plants do not completely remove azotes from wastewater, resulting in their release into the environment. Also, the biodegradation using activated sludge is effective only for two compounds tested, ketoconazole and climbazole, but despite complete primary degradation of azoles, complete mineralization was not observed. This indicates the presence of organic metabolites that may be more harmful than the initial compounds. It is also necessary to find an alternative or supporting method of removing remaining azoles, particularly fluconazole, and identify obtained metabolites in order to create complete degradation pathways. Thank you for your attention. If you have any questions you'd like to ask, I'd be happy to answer them here or by email. Thank you very much.
Okay, thank you for a nice presentation. So, do we have any questions, Dominika?
Yes, I have a question. Do you know what specific organism could be responsible for the process of removing azoles from wastewater?
Thank you for your question. I didn't conduct the studies on the specific bacteria strains because our main goal was to recreate the actual conditions in the wastewater treatment plant. However, it is a very good idea for the future studies to know which strains of bacteria are exactly responsible for the biodegradation.
Yes, thank you.
Yes, thank you.
Okay, so I see that there is a question in chat. So could you answer this from Camille?
Okay. Yes, it depends mainly which compound are we talking about, because tebuconazole, flutriafol, and epoxyconazole are used as fungicides, so they are mainly in the rural areas, just as I show in the determination of azoles in the surface waters. They were present in the field drainage channels. And on the other side, there are fluconazole, ketoconazole, or clotrimazole, which are mainly used in the medicine. So they are present in hospital wastewater, so mainly in the urban areas.
Okay, and Professor Axman?
Hello. It was very interesting topic because I'm working with pollutions that are present in water, mainly with anti-steroidal, non-steroidal anti-inflammatory drugs, so a little bit different, but still medical options. And I was wondering if you considered to work with bacteria green algae consortia to remove those pollutants, because it is more and more expanding area, I would say, because we know now that not green algae alone or nor fungi alone can remove all of those contaminations, as you also show us that it is impossible to obtain 100% of removal. So maybe you are planning joint action of fungi and green algae, just to improve this removal.
Yes, this is very nice suggestion. Thank you. Personally, I will continue the degradation methods, mainly using the oxidation processes such as photodegradation and Fenton reagent. However, your suggestion is also very nice. Thank you.
Thank you very much.
Okay, so thank you for the presentation and for the discussion. So let's move to the next speaker, Marta Magnucka from Adam Mickiewicz University in Poznań. So if you're ready, you can hit also a play on the presentation.
Welcome everyone. I'm Marta Magnucka and I am a PhD student at Adam Mickiewicz University in Poznań. My supervisor is Joanna Świetlik and the topic of my presentation is characterization of the microplastics retained in corrosion deposits of drinking water pipes. This is the plan of my presentation, and at the beginning I want to present some information about corrosion deposits and microplastic, then the purpose, methodology, and the results. Corrosion deposits are formed on the inner surface of metal alloy pipes as a result of electrochemical processes that involve the generation of a cathode-anode system or through the biological processes initiated by microorganisms present in the water. Corrosion deposits consist mainly of iron, oxygen, and carbon, but may also contain other elements such as sulfur, chromium, nickel, and zinc. Sediments are characterized by irregular structure and high porosity, which promotes the retention of the solid contaminations, which include microplastics. Contact of drinking water with sediment by limiting water intake or stopping the flow can lead to a decrease in water quality in the case of organoleptic parameters. Microplastics are polymeric particles smaller than 5 micrometer in size, characterized by a variety of shapes from irregular fragments to fibers, spheres, and flakes. The presence of microplastics in drinking water is a reason for public concern because these particles can accumulate in living organisms, penetrate the blood-brain barrier, and transfer harmful substances on their surface. For this reason, the current European Union directive on the quality of water intended for human consumption has included microplastic in the list of water contaminations that must be monitored. The purpose of my research is to determine the degree of microplastic particles contamination of sediments deposited on the inner surface of metal alloy pipes taken from the distribution network of a large urban agglomeration, and to assess the isolated particles in terms of their origin and residence time in the water supply network. Corrosion deposits can be used as an indicator and of the degree of particles contamination, microplastic particles contamination of water. The development of a methodology for the effective isolation and quantitative and qualitative identification of the microplastic could make it possible to determine the origin and degree of plastic degradation as a result of being in the water supply network. And based on the result, it would be possible to compare the effectiveness of treatment processes in the case of microplastic elimination. During the research, the coloration of the amount of microplastic particles deposited in the corrosion sludge was checked depending on the diameter of the pipe, the time of exploitation, and the location of the intake. The pipes were characterized by different amounts of deposited sediments on the surface. The sediments excavated from the pipes was dissolved with concentrated hydrochloric acid and then filtered to isolate microplastic particles. The filters, after washing with ultra-pure water, were dried in closed petri dishes and the filter were subjected to analysis using scanning electron microscope with EDS detector and Raman spectroscopy. The results of the analysis made it possible to determine the composition of deposits containing microplastic particles. High silicon contents were determined, indicating that most of them were silica or dusty forms of sand. In order to estimate the amount of microplastic particles on the surface of the filter, EDS analysis with mapping of carbon regions only was used. In addition, to increase the visibility of particles, the images had to be zoomed in and contrast increased. Particles were classified as microplastics when they had a visible shape and banded by clear edges. Particles with blur shapes and irregular pigmentation were not considered. As we know precisely the size of the filter area, mathematical calculations were carried out. The area of the filter was divided by the mapping area, and the resulting multiplication factor was multiplied by the number of particles counted, and then divided by the gram of sediment, and the results were defined in the number of particles per gram of sediment, or by the area of the filter and the number of particles per square centimeter. The first pipe was steel pipe. Microscopic images show different amounts of particles and their irregular distribution. The diameter of the pipe indicates that it is a water supply connection, and the time of exploitation of this pipe is 53 years. The second pipe is almost steel pipe. The diameter of the pipe indicates that it is a water supply connection, and the time of exploitation is 30 years. The third pipe is almost steel pipe, but the pipe had the shortest lifespan in the water supply network among the tested fragments, and the diameter on the pipe indicates that it is a water supply connection. And the last one is pipe made of cast iron, and the pipe was characterized by its large diameter and more than a century of use in the water supply system. And despite the well-developed deposit, there was small microplastic, which may be due to the large diameter of the pipe, determining the higher pressure inside the system, and the constant flow condition, and that are not favorable for particles deposition. The study observed a lack of correlation between pipe diameter and the amount of microplastic retained in the sludge. The results obtained for smaller diameter pipes are comparable to those obtained for a larger diameter pipe. No correlation was also observed between the amount of microplastic and the service life of the pipe. The amount of microplastic in the analyzed samples was also not influenced by the place of the collection, indicating that microplastic is constantly moving through the network with the transported water. Microplastic particles present in the water supply network may contribute to accelerated microbial corrosion by promoting biofilm formation as a result of the transfer on the surface of microorganisms along the network with them. More than 90% of the particles determined were characterized by a size smaller than 50 micrometer, and as the size of the particles increase, their content in the sludge decrease. The presence of predominantly small size microplastic particles suggested a high potential for microplastic degradation to nanoplastic under condition in distribution network. In addition, the presence of small-size particles indicates the low effectiveness of current treatment processes and water treatment station for removing such microplastic from water. And this is because the treatment process were not designed for microplastic removal. Based on the analysis of the elemental composition of microplastic isolated from the sludge, it is possible to estimate their residence time in the water supply network, a good indicator of which is the percentage of chlorine and reduced carbon content. A very low percentage of chlorine content indicates the particles' short residence time in the water supply system, since chlorine is used as disinfectant, and this suggested a short contact of the material with the chloride. In contrast, a high percentage of chlorine indicates a longer residence time of the microplastic particles in the water supply network. The analysis carried out allowed to determination of particles in the samples from polymers such as polyethylene, polypropylene, and polyethylene terephthalate, which are commonly used. Especially common in water supply practice are transmission pipe made of polyethylene. However, the identification of microplastic particles using Raman spectroscopy allowed the origin of the isolated fibers as allowed to determine the origin of isolated fibers as probably polyamide or polyester. To conclusion, the presence of plastic fragments was detected in all analyzed sediments. Microplastic content was estimated at 30 to 50,000 microplastics per gram of sediment, indicating their high potential to accumulate in corrosion products. More than 90% of the microplastics were fragments of size under 50 micrometer. The predominant plastic identified were polyethylene, polypropylene, and polyethylene terephthalate, by also polyester and polyamide. Very numerous particles of size that could not be counted by the technique used in the study were present in the examined sediments. These are most likely nanoplastic particles whose presence in drinking water may pose a serious health risk to consumers due to their ability to migrate into body tissue. There is urgent need to optimize technological processes in water treatment for the efficient removal of microplastic and nanoplastic from drinking water. And that's all, and thank you for your attention.
Okay, thank you for Ina's presentation. So we have time for questions. Rani? Okay, I see one chat. Was the methodology of the study developed by you, or it was taken from other scientific papers on the subject? Could you comment on that, Marta?
Yes, I use the methodology from the papers about the subject. I use SEM and Raman spectroscopy.
Okay, so are there any other questions? Professor Axman?
Hello. As far as I understand from your presentation, the main problem of plastic deposition in the pipes is their corrosion, yes?
And no, because
I mean that if the pipes didn't corrode, the plastic wouldn't deposit in them, yes?
in the case of the metal alloy pipes, yes, but in nowadays we used plastic pipes.
Yeah, this is my question. If these modern pipes are better, I mean that if using plastic pipes prevent deposition of microplastic in these pipes?
In this case, yes, but we have problem with the secondary microplastic from plastic pipes. So this is very difficult.
Avoiding microplastic, yes?
Yes, yes.
Okay, thank you very much.
Okay, so thank you, because I don't see any other questions. So thank you for a discussion. So let's head to the next live presentation now by Krzysztof Zadora, University of Applied Sciences in Nowy Targ. So if you're with us, please.
Yes, hello, everyone. Okay, can you see the poster?
Yes, yes, we can see.
Okay, and the next slide.
We see at least I can see whole PowerPoint, so you can make it like a presentation or something. I don't know, it's a F5 shortcut or something like that. Or at the top or at the bottom you have this near the scale, this left of the scale button that's will put you in the presentation mode.
Okay, 1 minute. Okay, and now?
Yes, now it's fine. Okay, so go ahead.
Okay, hello everyone. We are fourth year physiotherapy students from the Academy of Applied Science in Nowy Targ. Our topic of study is the health triad, a new therapeutic concept. The systematic review was prepared following the PRISMA. We conducted a literature search in online databases such as Google Scholar, PubMed, and ResearchGate. The search query used was health triad, and the language of the articles was limited to Polish and English. Publications met the eligibility criteria if they contain information about the health triad or at least one sphere: structural, mental, chemical. Here we have table of contents: introduction, aim of the study, materials and methods, results, conclusions, and bibliography. The concept of health is widely understood and defined in various ways. The World Health Organization defines health as a state of complete physical, mental, and social well-being. Based on the principle of a holistic approach to health, the concept of the health triad was developed by the father of chiropractic, D. Palmer. Health consists of three foundations: structure, biochemistry, and psych, which should be balanced, forming an equilateral triangle. When an individual experiences poor health, one of the three factors of the health triad is always involved, and in the case of serious or chronic health problems, two or all three factors may be involved. Sciences such as applied kinesiology enable us to assess the balance of the triad. Divisions of the health triad. Structure. Body, we often don't realize how stress-inducing external factors can affect our mental health and consequently structure issues. Biochemistry. What we eat. Additionally, we forget that it can also have a significant impact on the state of our structure and the efficiency of our mental sphere. Mental. Stress and external factors. The mental sphere encompasses cognitive and emotional functioning as well as the social sphere, which is responsible for the ability to maintain healthy interpersonal relationships. The aim of the study. Presentations of the key aspects of therapeutic approach in the health triad. In recent years, there has been significant interest in the psychosocial influences on health. Angel argued that the biomedical model fails to appreciate psychosocial considerations in illness, distorting perspectives, and even hindering patient care. A new medical model has been proposed encompassing the individual in their entirety, structural, mental, and biochemical spheres. Each element of human functions can influence another, where all aspects of human disease can be characterized as a convergence of their interrelations. Only a holistic view of the patients will guarantee the effectiveness of the therapeutic process. Breaking the exhaustive cycle. In addition to biological influences, there are many psychosocial factors that, as shown, negatively contribute to increased pain awareness. Pain experience can lead to catastrophic thoughts and subsequent fear of specific movements, and even overall avoidance of physical activity. Fear of movement can lead to social withdrawal, which can then trigger psychological and emotional depression or anxiety, which in turn can directly intensify an individual's pain perception. The goal of the health triad model is to interrupt and prevent the recurrence of this cycle. Most patients who presented for an initial visit with a specialist with higher levels of psychological distress showed a reduction in their distress levels after a few days from the visit. Researchers suggested that something other than physical treatment, such as active listening, providing credible explanations of pain, and uplifting spirits, could represent visible improvement for some individuals. Researchers suggested that something other than physical treatment, such as active listening, providing credible explanations of pain, and uplifting spirits, could represent visible improvement for some individuals. Patients' examinations according to the health triad. During the interview, we need to ask our patient about their functioning in each of these three areas, assess which one may be most burdened, and restore their body to homeostasis with appropriate therapy. We focus on seeking the cause rather than just the symptom. When we know the cause of the pain, we can quickly resolve the problem. A more challenging situation occurs when the pain is of unknown origin. We can describe such situations with left shoulder pain. It can be caused by excessive intake, chemical sphere, for example, of painkillers. This affects the stomach's condition. The stomach is innervated by the phrenic nerve, which has its roots in segments C3, C5. As a result, there is pain in the left shoulder. It's simple. Summary. Conclusions. For those experiencing chronic pain, studies have shown that considering psychosocial factors helps understand that one can live with chronic pain without simultaneously developing disability. The concept of the body as a self-healing mechanism is essential here, where the body's innate intelligence controls healing from within and specialist interventions only assist the body in optimization. The body has an innate ability to self-heal, and when the underlying obstacle is addressed, the body will be able to complete the process and no further interventions is necessary. Here is bibliography, and thank you for your attention.
Okay, thank you for your presentation. So we have some time for question, comments. Dominika?
Yes, what are the plans for future research in this topic?
Krzysztofie, are you still with us? Oh, he's not in the meeting. Maybe some internet drop, although kind of unfortunately after presentation, or maybe he don't want to answer any questions. Well, that's a shame. So I guess if he's not here, he won't answer any questions. That's bad. So sorry for that. So maybe is there a next speaker, which probably I'll butcher his name, or she's Mandy Kot. Probably not. Let me see the participants. Okay, I don't see this person, unfortunately. So yeah, so very nice theme to end the last oral session, unfortunately. So let's take a break till 3:45 London time. I encourage you to go to the page of the poster session, which I will link in a chat. Okay, so in the chat there's a link, and the password is also somewhere. 1 second, please. Okay, there's also a password in the in chat. So yeah, let's hit a break. Then from 3:45 to 4 p.m. 45 London time, there'll be poster session, and after that we'll be closing a conference day for today. So thank you very much for the last oral session, and see you soon on the poster session. So let's hit the break. Okay, time to slowly finish today's day and the entire conference. So thank you very much for attending the conference. Conference wouldn't be possible with of course all the attendance, all the people, all the organizers and staff. So this was the second such event. Previous one was a called Baltic Chemistry Conference. Now it's Natural Science Baltic Conference. Hopefully there will be another conference next year, also hopefully free of charge, and maybe even with wider like topics, although this conference has a very wide range of topics from chemistry, biology, although maybe I'm mistaken, but I didn't see much physics, unfortunately, but maybe next week there'll be some more. So I just recall that we had people from 10, the people who attend the conference were from 10 countries, 27 different research centers. We had 36 oral presentations. I don't have, unfortunately, by now information about the posters, but I imagine that there also were nice, quite few posters there and lively discussions over there. So, yeah. So thanks, of course, the patrons of whom this event wouldn't be possible, and honor patrons, of course. Of course, let's not forget the scientific committee, the Professor Anna Axman, Professor Marcin Marciniak, Professor Henry Pinto, Professor Katarzyna Wiktorska, Dr. Elżbieta Adamska, Dr. Emilia Godarek-Castro, Dr. Amond Desai, Dr. Agata Kućko, Dr. Małgorzata Kapusta, Dr. Anna Pacielejko, przepraszam, Dr. Maria Madej, Dr. Monika Hejna, Dr. Magdalena Miodyńska, Dr. Katarzyna Węgrzyn, Dr. Dawid Wnuk, Dr. Dawid Zdych, Dr. Wojciech Snoch, Dr. Wojciech Siwek i Dr. Maria Kochaniec. Dziękuję bardzo. Thank you very much for putting a nice work into this conference and helping us. Of course, let's not forget the special guest, Dr. Manuel Baza from the University of Newcastle and Dr. Joanna Drzeżdżon from the University of Gdańsk for interesting seminars at the beginning of each day of the conference. So all the attendants will receive a certificate of participation. It will be at most in 2 weeks, yeah, because we have to like kind of make them and send it to you. Also the awards will be in also in 2 weeks at most for the presentations and the posters. And if possible, we would like to take a group photo like on the first day. So if everyone would be so kind to turn on the camera, and then we'll try to make a group photo to memorize this nice event, and hopefully this will go more and more in the future of such conference. Yes.
Maybe turn off of the presentation because okay, thank you.
Yeah, and you can even like kind of, I know, switch the view somehow here, but I'm not sure, like together mode or something like that. I don't know. There are such options here.
Yeah, I have. This is big gallery, yes, but I take photo.
Okay, so let's wait. Maybe some people will turn on some also cameras. Nice doggo.
Yes, special guest of our conference.
Yes, he was listening to a lot of lectures today, so he's a bit tired already, but we all are.
Okay, thank you.
Thank you.
Thank you very much. So hopefully we'll see each other next year, maybe. Who knows?
Thank you very much. Bye.
Thank you. Bye.
Thank you. Goodbye.
Bye.
Thank you. Bye.
Thank you. Goodbye.
Thank you.
Bye.
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 Bye.